Hide the planet! Hide the planet! Shut up!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs, it's me, the Shy Hat. We're here to do HackerFrogs AfterSchool today. We're here to do HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're going to be covering on today's stream. Cypher asks, can I drink coffee? You can drink whatever beverage you want, my friend. Okay, so the schedule for today is over here, over at the HackerFrog subreddit. If you're not signed up, well, you can sign up over here. We also have a Reddit, we've got a Discord. Here are the links for both of those, and this is what we're going to be doing on today's stream. So we're going to be warming up with puzzle games. I really miss playing puzzle games, and they're a way of thinking outside the box and doing some problem solving, which is what we hackers like to do. So today we're going to be playing a game called Leap Year, and that's going to be the first topic for today's stream. For the second topic, we're going to be doing some cryptography over at OLIcyber. OLIcyber is an Italian cybersecurity education platform. We're going to be taking a look at some of the cryptography challenges over there. And coincidentally, or maybe not so coincidentally, we're going to be starting our HackerFrogs AfterSchool cryptography course. We're going to be taking a look at cryptography over at the Crypto Hack platform. And Shalashi says, finally I can attend the late night streams. Vacations are fun. Late night streams. Are you in Europe right now? Let me know. Okay, so that's going to be the third topic for today's stream. The last thing we're going to be doing today is we're going to be doing some Windows Active Directory hacking over at HackSmarter, and they've got a machine called MartiniAD. So we're going to brush off our Windows hacking techniques, and we're going to try to compromise this Windows Active Directory environment, and that's going to be the last thing we do for today's stream. I'm in Europe, 11 p.m. for me. Yeah, I know that people in Europe, it's getting kind of late right now. All right, so without further ado, let's start into our first topic. We're going to be doing some puzzle gaming. And one of the things that I really like about a certain genre of puzzle games is that they're very much about learning the rules, and you solve the game by knowing the rules. So we'll put an hour on the clock for that. And the game's called Leap Year. If you want to learn more about it, there's a link over here. I think it's on sale right now. You can get it for around $8 American or something like that. Something not super expensive. And what we're going to do is we're going to try out the game, and we're also going to be doing some documentation and writing down all of the rules that we find out. Okay, so let's go ahead and get started. So let me start up the game.
佐克波普
Okay, so you should be able to see the game, and you should be able to hear it as well. If you find that the music is a little bit too loud compared to my voice, let me know, and I'll change the volume in the game. Okay, so let's do a volume check right now. Can you hear me over the music, or is it too loud? Okay, so this is we're going to be playing this game on the controller. I think it's okay. That's great. That's great. Let's go ahead and get started. So we're going to play the game. We're going to play a new game. And we're going to learn some of these rules. So we've got this little guy over here. We need to pick up each one of these days over here because the game's called Leap Year. And there are 29 days a leap year. So we need to figure out the game, we need to figure out the rules, and so immediately what you would try to do, there's only one button in this game to interact. There's a jump button. So if you jump, you die. If you jump, you die. So how are we supposed to reconcile this? Okay, let's go ahead and write down our first rule of the game, and let me go ahead and pull it up. Hold on. Okay, so the first rule is PPX, hello, nice to see you here. We're just playing a little warm-up game. So discovered rules. If you jump... if you jump normally, you die. Okay, if you jump normally, you die. Let's make this a little bit bigger. And so this is level 0, where we figured it out. And let's go back. So there's a bunch of these rules that we're going to be discovering today. Okay, so we're dead, but we can come back. So the thing is that if you jump, and if you jump normally, you die. But if you stand over here and you jump, you don't die. So what are we supposed to learn from this? If you jump, but you don't jump to the full height of your jump, then you don't die. Okay, so let's write down that rule then. All right. If you jump, but you don't go to the full height of your jump, you don't die. Okay, that's another rule. And let's go ahead and pick up this this first flag. I'm going to call them flags because, you know, I come from like a CTF background, and when we do CTF exercise, we call them flags. So what else is over here? So I mean, we see some spikes. I mean, if you've been playing a lot of video games, you know that spikes will kill you. But just to make sure, this is another rule. If you land on spikes, you die. Okay, let's go ahead and record that rule. Okay, if you land on spikes, you die. Okay, and I guess we need to write down where we discovered these rules. Actually, if you land on spikes, you die. This is level 1. This is where we figured it out. Okay, that's the next rule, and let's go back to the game. Alright, so here we can jump, and we don't die because we don't jump to the full height. But if we jump to the full height, then we do die. Okay, let's continue. So this is okay because we're not jumping to the full height. Or rather, we are jumping to the full height. I guess it's more about falling down. If you fall from a particular height, then you die. It looks like it's like two squares. And one of the things you need to realize about this game is that you can turn on a grid. And the grid, so we're falling one square in height here. Okay, so if you fall more than 2 squares in height, then you die. Okay, let's record that. If you fall more than 2 blocks in height, then you die. So we figured that out in level 1. Okay. Okay, 2.5. Is it 2. Is exactly 2.5? I mean, we can do a little bit of experimentation. So our full jump is 2. Our full jump is 2 squares. So if you take a look at the grid here, that's about 2. Okay, let's continue. So the rules are going to get... We're not going to really learn any new rules for a little while now. I think I played through the first, like, 10 levels of this game. Okay, so if we fall down here, then we die. But we need to land over here. Okay, and then we can get the second flag. Oh, so if we can't just fall. If we fall, we die. So what we need to do is we need to reach this platform over here and then fall down gently like that. Okay, so that's level 2. And we've got a choice over here. We can either go to the right or we can go to the left. Let's go to the right. So that's 16. So I mean, we don't know the rules. We don't know enough rules to get number 16. I'm pretty sure we're supposed to go in sequential order. So let's go over to the left. Okay, up here, up. So we can jump over here, it's fine. We can get number 3. Okay. And here, let's see if there's like a secret passage over here. Okay, no secret passage. Okay. So if we jump up here, then we die. Yeah, okay. Alright. So I guess what we need to do is we need to do some tricky jumping. Like this. And like this. And we can land over here. And there's number 4. So number 4. Okay, great. We can land down here, then down here. How do the file types go? Which kind of file types are we talking about? Is the unknown. So we've got this guy over here, and this is actually a rule in and of itself. So if we land on these people here, if you land on the people, then you don't die. SVG WebP. So what do you want to know about SVG and WebP? These are both image file types. I mean, I'm not really an expert on these things. Okay. Does this guy come back? Does he come back? I guess he doesn't. Okay. So this is another rule. So rule number 4. So rule for level 4. Let's record this. Okay, if you land on a person, they break your fall, and you don't die. So this is level 4. Okay, let's continue. And there's number 5. So we know that if we land on these people, then we don't die. So we can just jump up here, collect number 6, and we need to land on this person so that we don't die from the fall over here. Okay. Is there a secret passage? There is a secret passage over here. Okay, so that's after number 6. Oh, this is so that we can come back the way we came. Uh-oh. I don't think we can make this jump anymore. Because there's this, uh-oh, okay. Alright, land on this guy. There's number 7. Okay, you're still on the rules. I'm still on the rules, I'm sorry. I forgot to change over to the game. Okay, let's let me demonstrate. Okay, I think I was talking about. So we're taking a look at the whether or not we could. Oh, we can't. Okay. So if we don't have a person to break our fall, then we're certainly going to die. Okay. Jump on these guys. This is flag number 7. And we can Okay, so we can't jump up there. Our jump isn't big enough. Okay, so we can. Oh, that doesn't work. I think what we need to do is we need to do a little bit of like a special jump like this to get ourselves across. Okay. We can jump up here. Uh-oh. Jump, jump, jump up here. Okay, and this is where we discover another rule. So this rule is that if you don't land on spikes, you can walk through them. So I guess if you walk on the same level as spikes, you can walk through them. So we'll record that rule as well. So what level is this? This is level number 7. Okay, Christian Ring says, "Are we streaming games now? But I see the connection to cybersecurity." I mean, we're just talking about rules and learning rules, because I mean, hacking is all about taking advantage of rules. Okay, so let's record this rule. So this is level number 7, I think. Level 7. If you walk on the same plane as spikes, you don't die. Okay, next rule. Okay, and let's go ahead and put the game back on. So we can jump here, and I think we can get to number 8 pretty easily. Okay, number 8, and then I guess we'll just keep on going. Is that level number 9? Okay, so there's a flag here, but it's not actually. Where do they want us to go? Do they want us to keep on going this way? Okay, so there's 8. Here's number 9, number 10, and then number 11. Why are they all bunched up like this? Okay. So that's number 9. Whoops. Jump up. Hold on. Okay, so we got 9, 10, and 11. And here we need to jump on these guys' heads. I think I need to bounce off of this guy's head to land safely. So like this? Yeah. But now how do I jump safely? Because I can't. Okay. Well, now these guys are alive again, so I can jump on their heads. Okay, and then I can need to jump on this guy's head and bounce. Okay. Oops. I'm really good at this. Nope. we got to cross. Oh, I forgot about the rules. Okay, and then jump on this guy. Whoops. We need to land here, and then down here. Okay, now we've got a flag. We can continue. So did we learn any rules? I don't know if we necessarily learned any rules over there. Okay, and now we can go up, I guess, from here. Set this flag first. Jump up. That's 22. So it doesn't make sense that we'd be able to collect that. We can jump up here. Jump up, jump up. I think we can collect number 22 if we don't land on the spikes. So if we jump up here, yeah. So we didn't land on the spikes. So we can collect 22. Where does this go? We don't know. We can move up here. Okay, and then go up. There's number 13. Oh, okay. Okay, walk up the stairs, and then we got number 14, Valentine's Day. So I think what we need to do is we need to jump off of we need to bounce off of these heads to get number 14. Okay. Alright, we can climb up here. And we've got these guys. We can set a flag. Okay. And we've got flag number 15 over there. So let's... Can we jump up here? Yeah. Okay, so that's number 15. So here's another fun rule that I figured out. So if you jump from a height of more than, I think it's like more than 4, then you bounce. This is how it goes. Oh, nope. If you fall from a height of more than 5, so that's like 1, 2, 3, 4, 5 up to the ceiling there, then you'll bounce. So it's kind of a weird rule. So if you fall from too great a height, then you bounce. So how many blocks is this? 1, 2, 3, 4, 5? Okay, let's record this rule. So this is level 15? Yeah. So if you fall more than 5 blocks in height, then you will bounce up 5 blocks in height. Okay, and this is level 15. Okay, and we will continue. So there's only 29. There's 29 of these levels, and we're at level 15 right now. So I wonder if we can finish the whole game today, or if it's going to take two sessions. Not sure. Okay, let's continue. Okay, jump up here. You bounce. Actually, you don't bounce 5 blocks in height. You only bounce up 4 blocks in height. 1, 2, 3, 4. So I'll record that the next time we record a rule. Oh. We go here, we bounce. Okay, and then we drop here and we bounce. and then we drop down here and we break our fall. So if we go down here, I'm pretty sure we can bounce if we jump up to the full height. Yeah. Go up here, and then we... Oh, we did a double bounce. That's good. Okay, so let's continue. So we can go down. So there's like a diagram. There's a diagram over here. Which it's I think it's trying to illustrate like part of the level. A part of some level where there are some interconnected pipes. So what I'm talking about is in the middle of the screen right now. Okay, we'll try to look out for that. Can we... Oh, we can't jump down there. Okay, so we can't jump down here. We need to bounce. But I don't think we can bounce either. Okay, drop down. Okay, Amin Egg, hello, nice to see you here. Okay, so let's continue. So we're gonna break our fall with this guy. Done. Okay, so this looks like exactly what we saw, because we've got the things that are connected together, and then what they wanted us to do, I think, was to jump up at an angle. Let me set the flag over on that end first. Okay, so set the flag here. And I think what they wanted us to do was to jump like this. Nope. Whoops. So it was something about... Oh, we might have to bounce. I think we can bounce if we jump from like this height. So if we jump up, and we should be able to get 5 blocks of height and then bounce. So like this. Yeah, okay. So we... Well, I mean, that wasn't a flag. What is this? Jump up? So I think we need to bounce here, because we can't survive this falls from this height. Okay. Bounce. And then bounce here. Okay, great. Okay, we've got an ad running on Twitch right now, so we're just gonna wait it out. Tig, hello, nice to see you here. What is up? We're just playing a little puzzle game, trying to figure out this system. So we learned a bunch of rules about this platform game. Okay, last flag was set over there, so we're just gonna grab this flag. We're gonna wait for the Twitch ad to finish up in about 30 seconds. Sounds fun. Yeah, we're trying to figure it out. So how large is this fall? So that's like a 4-block fall. If we jump over here, do we bounce? No, we don't bounce, we just die. Okay, so we can't go that way. So the only way forward, I guess, is to jump into the dirt. So we're just gonna jump. Oh. What happened there? So this is a new rule, I guess. If you jump how many blocks is that? 1, 2, 3, 4, 5, 6, 7. 7 blocks. So if you drop 7 blocks into some dirt, then you tunnel into the dirt. Okay, let's record that, because that's a new rule. Okay, we figured out if we bounce up 4 blocks in height. So this is level... If you fall more than 7 blocks in height, then you can tunnel into dirt. I mean, I'm not exactly sure if it has to be dirt or something else. What level is this? This is still level 15. Okay, so we've got a new rule. Okay, and let's see if we can... So we're tunneling through this dirt. We go straight down. We can't really control ourselves. We can control left and right. Yeah. So when we're tunneling, we can control left and right. Or we can go straight down. So which direction do we want to go in? Maybe we'll try going all the way right. Oh, that kills us too. What happens if we go all the way left? Nope. So we need to avoid that. Which direction can we go in that doesn't kill us? Okay, now we're good. What is this illustration here? So it's like people, but the person in the center is a crown? Are we supposed to look for this kind of pattern? So it's like 3 people land in the center? Okay, so we can go left from here. Well, left or right? Okay, looks like we can't go left. We have to go right. Okay, SysOS, hello, nice to see you here. Yeah, we found a Steam game. So this one's called Leap Year, and the name of the game is up at the top of the screen on the overlay. Okay, so I guess what we need to do here is we need to bounce. So if you drop from more than 4 blocks in height, then you bounce. Oh, and then we die anyways. So how do we avoid dying here? 1, 2, 3, 4. Do we need to bounce off the screen? Maybe? Oh no, I think I know what we need to do. So bounce, 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 and then that's not a great enough height to kill us. We get down here, and then we get down here. And so remember that you can walk through the spikes, you just can't land on the spikes. And I'm pretty sure that you can... So we need to find a way to land... Okay, we can't land on the spikes. I'm trying to land so that we hit... Can we? I mean, we can't bounce over the spikes. We can't jump over the spikes. We will use the power of HackSmarter, of course. Yeah. Of course. So how many squares do we jump up here? So it's 1. So do we bounce? No, we don't bounce. We're not high enough. Can we just jump over? No, we can't jump over either. Maybe we can jump here? That doesn't work. Oh! It was just that easy. We can't land on the spikes. Land 7 more times on the spikes in this session. Yeah, we're just trying to figure out how to not impale ourselves on the spikes. So we just need to jump from a certain height. So we'll jump up here. Okay, and then we bounce. Because we jumped from a great enough height. Okay, so go up here, up. See, Haxer did. Brute force worked. Kind of. Okay, so there's number 16. Alright, that was close. So we can get number 16, like this. And we can go either left or right. So if we try to go left... Okay, we've been here before. Okay, I think we need to land on some spikes. Okay, so we can go right from here. And they're trying to illustrate some sort of rule over on the right. So if we jump, we can jump over the spikes, and then if we're on the same plane, then we're okay. There's number 17. I think this is where I got stuck. So I think if we bounce, if we drop down at a specific angle, then we'll drop down enough squares so that we bounce. Oops. Okay, but then... And then number 23. I mean, I'm pretty sure that we're not supposed to collect number 23 right now. We're supposed to collect it after we learn some more rules. But... nope. Nope. So this is some... this is some input error here. Okay. Okay, so we bounced, but this still isn't enough. We can't drop from 2 blocks without killing ourselves. And we don't have enough height to be able to bounce. G is unforgiving if H is too high. Is this a game or a learning challenge? So we're just trying to... We're doing some puzzle gaming because this puzzle game is all about learning rules. And most of hacking is just knowing the rules. If you know the rules, then you can exploit the rules. Not that this game is about exploiting anything, it's just that it's a very tricky game unless you know the rules. So we can't... Yeah. That kills us. Actually, I think we might be able to tunnel, because we've got this really high platform over here. So if we jump up here, and then we jump down, then we should be up high enough so that we can tunnel. So if we jump and we drop down 7 blocks in height, so that's 1, 2, 3, 4, 5, 6, 7, then we tunnel into the dirt. So it's like this. We just need to land in a way that doesn't kill us, and then we're okay. So... oh, that still isn't good enough. So where could we land? Where we don't drop from a height that kills us. Landing is overrated. Well, I mean, it's not the crash. It's not the crash that kills. It's not the fall that kills you, but the abrupt stop at the end. Okay, up here, up here, up here. It's not the fall that kills you, yeah. So if we can tunnel down into the dirt, where do we want to land? So maybe we can aim for... maybe we can aim for this swirl. So the swirl in the middle of the screen, down near the bottom. If we drop down there and we drop exactly down to the platform with the 17, then that should be low enough so that we don't die. Up here, up here. Okay, it has to be further than that. Okay, try maybe going right so it'll be 4 squares. Going right? So that's going to be 4 squares. And then maybe we'll bounce? Oh, you know what? I'll try it out. Well, let's try it out. So if we go to the right, maybe we can bounce after we tunnel. Oops. That doesn't seem to work. So what happens if we go all the way right? Yeah. So that's a fall of 3 squares. So I guess we can't... I guess another one of these rules might be that we can't bounce after we tunnel or something like that. Up here, and then let's try going all the way left. All the way left is no good. So we need to make it very, very precise, where we need to land at the corner. So we need to land at the corner underneath this swirl over here, but we need to exit at the corner and then land precisely on the platform where the 17 is, so that we only drop 2 squares. We got pretty close. So close, so close. I wish this game were a little bit slower. Nope. Maybe we're supposed to land at the middle of the swirl? I'm not sure. Let's give it a try. No. Maybe we're supposed to hit the swirl this is so absurd. Can we Okay, there's an even higher platform. Maybe just jump from there. Oh, well, I mean, this brings us to... This just brings us back to where we were before. Anyways, I want to retry. Okay, so even higher platform. Yeah, maybe we can jump from there. So what is that? Up here, and then... I'm not sure if I'm getting close or not. Okay, it worked. Wow, I just need to make sure to land at a very specific angle. Okay, we got to level 17. So 17 is done. And does this lead anywhere? I don't think so. So I'm pretty sure we don't. There's got to be some way to get the number 23 up there. Maybe we can get it later, but we don't know what the rule is yet. Okay, so there's nothing here. Okay, and I think we need to... Now, how could we get the number 23? We could bounce? We don't bounce that high. We bounce 4 squares up in height. Yeah. So we can't use the bounce technique to get there. So if we jump up too high, then we burrow. Joseph, hello. Can you jump onto it from a higher ledge? I mean, if you jump onto it from a higher ledge, then we activate another rule, and that rule is if you jump from more than 7 heights in... if you drop more than 7 blocks in height, then you tunnel when you hit the ground. If you drop from more than 4, then you bounce at the end. So this is a bounce, but then when we come back down, then we die. Okay, let's just keep on going. Okay, and there's number 18 there. So we should be able to get number 18. Let's set a flag. Oh, if we set a flag, then we can't. I think I've. Oh, I remember. You need to land on this guy. Okay. So we need to find our way over to number 18 from above, and then drop down. Okay, up here. Oh, that doesn't work. So just keep on jumping like this. So we need to make our way over to the left. So we know that if we... No, that's not high enough to bounce. Jump, jump, jump. don't jump high enough. Do we jump high enough? No, we don't. We don't jump high enough. Jump, jump. So maybe if we jump from this height, then we can bounce. Yeah, okay, okay. So if we bounce, we can go over here. Okay, so we can get number 18, and maybe we can go over to the other side. Okay, that doesn't work. Oh, I didn't know that this was a ceiling. Okay. So we can go this way. Okay. Looks good. Let's see. Fair asks, I have a quick question. Can you copy a file in Windows and copy it to Kali Linux? Can you copy files from Windows and then move them over to Linux? Yeah. I mean, files are files. It doesn't really matter what kind of operating system you're dealing with. Both operating systems will work with files from either operating system. It's executing them is the issue. You can't use binaries that were designed for Windows on Linux and vice versa. Okay, so there's number 19. Okay, 19, done. Actually, can we... Yeah, can't do that stuff. So there's 19, 20, 21. 19, 20, 21. They're here. So is there some sort of rule that we're supposed to understand here? Okay. Oh, there's a... What is this illustration? You know what? I think I'm going to take a screenshot of this. So it looks like, So, do you see what I'm seeing? There's some sort of illustration on the right-hand side of the screen. I'm going to take a little screenshot. Okay, and then we'll carry on. So what do you think this is going to... How do you think this is going to matter? We need to look for something... We need to look for a room that kind of looks like the thing that they're illustrating here. And then I guess we'll do a bunch of experimentation. So we need to look for a room that kind of looks like the diagram on the right. I guess we'll be on the lookout. But right now I don't see any way we can get to number 20 and number 21. I think, well, I mean, if you're talking about like a share that you can switch between different VMs, you can set up a share in Kali Linux that is connected to your host system. So down here, I think we might be able to bounce if we come at it from the correct angle. Okay. Whoops. Yeah, the problem is that we need to not die after we bounce. Okay, that's good. Up here, and then... Is this the room they were talking about? I'm gonna pull up the screenshot. Okay, so I think this is the room they were talking about in the screenshot. So it's like 4... Maybe not. Okay, it's gonna go up. So this leads up. Up. And this leads me to the main hub, I guess. Oh, you know what? We can cross over to this side now. So we haven't been to this place before. What is this? So we see a lock. So we're supposed to come back here at the end of the game or something? Because these are all the flags that we've collected so far. I mean, we could... Okay, that kills us. I guess we keep on going down then. Okay. And I'm pretty sure we can bounce here. Oh, but if you bounce, you die. If you bounce, you die. We haven't learned a new rule in a while. I guess we need to look for that room that they were illustrating. We'll go back to the start. So there's an ad on Twitch right now. We're not really doing anything too exciting right now, so I'm just going to keep on going. So we could probably bounce. Let me... Huh. Jump, jump, jump. We can't do the same jump over here. Ah. Okay, so we managed to bounce there, so we're safe. So we're supposed to be on the lookout for a funny-looking room. No, we can't move through here. We're essentially going back to the beginning, and we're looking for a specific-looking room. Down, down, down. Huh. Can we drop down there safely? Because we drop down... It doesn't look like we can drop down here safely. So I guess we're kind of stuck. Alright. left in this portion of the stream. Let's try this other section over here. So I'm pretty sure you need to jump, bounce up here. And then we are up in here. Where's our flag? It's over here. Okay, so we can experiment a little bit. Okay, so that's free for jumping. Yeah. So there might be a way to get up top somehow. Wait, is this an area that we've never explored before? No, I think we have. Yeah, this is where we learned how to bounce and apparently die. Then we can come back here for some reason. Come back the way we came. And this is where we learned how to tunnel. So, I mean, I'm pretty sure we can bounce over here. Bounce here. Sorcery Pwn Adventure. Sorcery Pwn Adventure? I don't know if I've played that game or not. Okay, let's see if we can... So we can... we can't bounce over here. So this is where we learned out that we can tunnel. I wonder if there's a good place to tunnel to from here. So these are all these spikes. Oh. I don't think we can go anywhere from here, though. Because we just land on the spikes. Okay, we'll come back to this next time. And, yeah, so this was an exercise in rule learning. Let's go ahead and quit out. Next time we do this, hopefully we can get to the end, because we only have 1, 2, 3, 4, 5, 6, 7. We only have 7 more flags to go in this game. Okay, so what did we learn? We learned a bunch of different rules in this game. If you jump normally, you die. We learned that in level 0. If you jump, but you don't go to the full height of your jump, then you don't die. We also learned that in level 0. If you land on spikes, you die. If you fall more than 2 blocks in height, then you die. So this is basically like the most basic mechanic of the game. You need to avoid falling from certain heights. And X5, hello, nice to see you here. Keen to see how far you get. We got to, I think it's like level... Which level did we get to? Hold on, let me boot up the game one more time. I need to figure out how far we got.
Sock Bob.
Okay, so we got to level 20. So we weren't able to get... Yeah, we got to about level 20. Alright. So we figured out these rules over here. If you walk on the same plane as spikes, you don't die. And if you fall more than 5 blocks in height, then you bounce up to 4 blocks in height. So we learned that in level number 15. And if you fall more than 7 blocks in height, you tunnel into the dirt, which is what we also learned on level number 15. So let's go ahead and move into the next part of today's stream. So the warm-up is done. So that was topic number 1. We're doing topic number 2, and we got topic number 3 on deck. So we're going to be doing our cryptography challenges. Great. Okay. Before we get started with the cryptography challenges, let's go ahead and put on some new music. Okay. And let me know how the volume of that music is compared to my voice. I don't want it to be too loud. Okay, language barrier. Which language barrier are we talking about? Oh, okay. Anyways, let's save this out, and we'll come back to this this rules file over here when we learn some new rules. It's about 15% too loud. 15%, you say? Let's turn it down a little bit then. Okay, and what we're going to do is we're going to go over to OLIcyber. So OLIcyber is an Italian cybersecurity education website over at training.olicyber.it. And the good thing is that even though the website is in Italian, we can translate it and get access to all these challenges ourselves. It's a very good place to learn about all sorts of cybersecurity concepts. So they've got a bunch of categories for these challenges. They've got miscellaneous, they've got network security, which is essentially packet capture forensic stuff. They've got web security, which is pretty common in CTF challenges. They've got cryptography. They have software security, which is their interpretation of binary exploitation and reverse engineering. And those are the categories that they have in their challenges. So today we're going to be taking a look at some of these cryptography challenges, because we're going to be starting a cryptography unit for HackerFrogs AfterSchool. So if you have an account over at the website, you can join along with us over here. Okay, we've done a number of these. Let's see if we can do cryptography number 6 over here. I'm not completely sure whether or not we've been doing walkthroughs or doing write-ups on these challenges as we've been moving along. So we'll translate these challenges from Italian to English. Okay, and what's going on? So this is crypto challenge number 6. One more time, please. Using Vernum's cipher is perfect in the price. Perfect in the price. I mean, this is the translation's not perfect here either. Intuitively, even by attacking the key by brute force, the key is obtained all the clear text of that length. It is therefore not possible to distinguish the correct one from the others. You have not earned information. So a fundamental principle in this encryption method, by no coincidence, the one-time pad, is to never reuse a key more than once. In the case that there's a reuse of the key, weaknesses are introduced. Knowing something of one of the messages, you can decrypt them without having information about the key. Okay? In this case, the use of XOR is in operation. There's some very convenient tools for this type of attack called crib drag, for example, MTP. So I mean, I don't think I've done this kind of challenge before, but we'll give it a try. If you want to give this a try yourself, there is, well, our download links are over here. So the actual cipher is this. If you can figure it out, let me know. Actually, I'm not sure if you can download this file, because it looks like my cookie has been included in there. And in fact, because my cookie's in there, what I'm going to do is I'm going to log out and I'm going to log back in. Okay, just a second, everybody. We almost had his session. Almost, huh? Okay, let's log back in. So this is what you need to be careful about. Sometimes the auth parameter there had my session cookie in there. But anyways, let's go ahead and try out this challenge. So cryptography number 6, one more time. So I guess that what they're talking about is not reusing keys for one-time pads. Hold on, let's translate this thing again. Okay, Vernum Cipher. So Vernum Cipher, I don't know. I mean, I'm not too sure what this is. We can do a little bit of research. I'm guessing this is one-time pad. Okay, let's read about this. So Vernum Cipher in cryptography. Vernum Cipher is a method for encrypting alphabetic text. It is one of the substitution techniques for converting plain text into ciphertext. In this mechanism, we assign a number to each character of the plain text. So A equals 0, B equals 1, until Z equals 25. The method to take the key. So in the Vernum Cipher algorithm, we take a key to encrypt the plain text whose length should be equal to the length of the plain text. So the encryption algorithm is assign a number to each character of the plain text and a key according to the alphabetical order. And then bitwise XOR both of the numbers, okay, corresponding plaintext key character number and the key character number. Subtract the number from 26 if the resulting number is greater than or equal to 26. Even if it isn't, then leave it. Okay, so what do we have here? So the plaintext is OAK and the key is SON. So for each one of these plain text and key combinations, so the plain text is O and the key is S. So O equals 14 in the alphabet, and then S equals 18. So these are the binary numbers associated with both 14 and 18. You do the bitwise XOR operation, and then we get the number 28. So because the result is 28, we need to divide it by, we need to modulo it by 26, so that we get something that is divisible by 26. So if you modulo it, then you get the remainder of 2, and 2 is C in this system, so the ciphertext becomes C. So you need to do an operation like this for all of the plaintext key combinations to get the eventual message. Okay, so the new ciphertext is after getting the corresponding character from the resulting number. So the ciphertext for these three combinations is COH. Okay, so if we got this as our plain text and and this is the key, then we'd have to do all the operations for all these. Okay, now bitwise XOR the plain text and the key. Okay. So for the decryption, apply just the reverse process of encryption. Okay, so the implementation of Vernum Cipher in Python is this one over here. Okay, so if we just copy this and then go over to, I don't know, good old text editor, vernum.py. Let's call it vernumcipher.py. Okay, and then we so we got example usage: if name equals main, plaintext equals hello, key equals generate key length of plaintext, print plaintext key, print plaintext print key, ciphertext encrypt. Okay, so I guess what we need to do is we need to create. We should have to provide a plaintext and then provide a key. So what they've defined here is to generate a key. So I guess what they're doing is they're generating like a random key. So if we go in here and we want to create some plain text and encrypt it. So it's like HackerFrogs like and subscribe. I guess maybe we need to do this all in one string. So HackerFrogs like and subscribe is the plain text. We need to encrypt it using Vernum cipher. So plain text, HackerFrogs like and subscribe, key, ciphertext. It looks like the script isn't quite right. Let's go back. So plain text, key, ciphertext, decrypted text. Ciphertext, decrypted text. So the ciphertext is derived, and the decrypted text should also be derived. Okay, so advantages of the Vernum cipher here: perfect secrecy. With a truly random and unpredictable key of the same length as the message, the Vernum cipher provides perfect confidentiality. And you know what I forgot to do? I forgot to set my my time limit for this exercise. So let's put 45 minutes on the clock and keep on going. So unbreakable with a truly random key. So in theory, if the key stream were truly random and used only once, hence the name one-time pad, the Vernum cipher would be unbreakable. The key stream is the same length as the message, and the likelihood of any decryption of the ciphertext is equal. No pattern recognition. Unlike other encryption algorithms, the Vernum cipher does not produce a pattern of ciphertext that can be used to break the code. Each character of the ciphertext is encrypted independently, and it's a simple algorithm. Both the encryption and decryption algorithms are simple and involve a bitwise XOR operation. This simplicity can be an advantage in some situations. The disadvantages of the Vernum cipher here: key management. The main practical challenge of the Vernum cipher is the management of truly random private keys. The key must be the same length as the message, and a new key must be generated for each message. Distributing keys securely is not a trivial problem. Key reuse compromises security. If keys are reused, the security of the Vernum cipher is compromised. If an attacker intercepts two ciphertexts encrypted with the same key, he can use XOR to cancel the key stream or reveal the XOR of the two plaintexts. This could potentially leak information about the original message. Okay, so what are we given in this challenge? So we're given a ciphertext over here. So I'm just gonna download this, and this is crypto challenge number 6. I'll move the downloaded file over here. Okay, and what does this look like? This looks like hexadecimal. Well, this might be like hexadecimal ASCII or something. So to everybody who wants to solve this along with us, I'll make a paste of this. Like, what is it called? Paste bin? Yeah. So I'll make a paste of this so you can take a look at this yourself. Okay, let's see. Create new paste. Verify I'm human. Thank you. Okay, so this is the paste if you want to take a look at it. Okay, and the other thing we could do is right now we could put this in like CyberChef or something. So CyberChef, This is our favorite tool for doing all sorts of transformations on data. Oops, that's not it. Okay, and immediately what I want to do with this is I want to do a from hex to see if I can turn this back into something that we can read. Okay, so this just turns it into mostly garbled bytes. Okay, AVC, hello, nice to see you here. Are you doing some challenge from somewhere? Yeah, we're doing a challenge from OLIcyber. So OLIcyber is an Italian cybersecurity education platform. You can sign up for free, and you can translate all the challenges from Italian to English, or whatever language you like. We're currently doing this challenge, and it's a cryptography challenge. They've actually told us what is going on here. So they're talking about Vernum cipher. So I'm guessing that the ciphertext that we got is Vernum cipher. Okay, so and they also talked about a crypt drag attack, MTP. So MTP is some sort of script that does the crypt drag attack. So XOR is being used as an operation on this stuff. So MTP, keys in one-time pad encryption should only be used once. When they get reused, we can do a many-time pad attack. Okay, so MTP stands for many-time pad attack. Okay, sure. MTP Interactive uses an automated cryptanalysis to present a partial decryption which can be solved interactively. Okay, we need Python 3.7 or above. Shouldn't be a problem. Okay. Yeah, I mean, I'm trying to make it as easy as possible for people to follow along with the stream. Okay, so I guess what we need to do here is we need to clone the repository. So we'll just copy this. Everybody, if you want to know what repository I'm looking at, it's this one. And then we'll copy the repository over to this directory here. So git clone this thing. And we'll also copy over the output file over into this directory as well. Okay, and setup.py. Do we need to install this? So pip install MTP. Oh, pip installed MTP. I mean, we probably want to do this in... Let's call this our, I don't know, many-time pad tab over here. And we're just going to create a Python virtual environment. Just a second, everybody. I need to grab my notes for creating the Python virtual environment. Okay, so it's Python m venv myenv, for example. Yeah, Python m venv name. Yeah. So it's, and then a virtual env myenv, and then source activate, and now we're in the virtual environment. So the reason why I like to use virtual environments when I install new Python modules is because I don't want the new Python module to interfere with what I've got already. So we can do it from here, pip install MTP. Okay, and then we can probably run it from here. Yeah, use a virtual environment when you can. And then how do we run it? So MTP examples sample.ciphertext. Okay, and it says cursor movement is very similar to Sublime Text. Letters can be entered using the keyboard anytime. I mean, I guess we can give it a try. It's just MTP and then the name of the file. MTP output.txt. Okay, so how is this working? So AVC says, are you doing all this for fun, for a job, or for teaching others? I'm here to present cybersecurity content on Twitch and on YouTube. Because this is the type of channel I would have really appreciated when I was trying to get into cybersecurity. So it looks like the message might be in Italian. There is reuse, right? Okay, can we make this a little bit bigger? Yeah. Okay, cursor movement is similar to Sublime Text. Left, right, up, down for simple movement. Home and page up, page down for larger movement. Left click for jumping to the mouse cursor. Okay. Letters can be entered using the keyboard anytime. The menu can be opened with the escape key. The export button in the left will write the JSON state of the decryption to a file named result.json by default. Okay. Use the O flag to specify the desired file name for export. Okay, so we got some examples in here. I see the word flag, and we're probably dealing with an Italian message. The thing is that if the message is in Italian, I don't know what is going to look correct. Okay, let's take a look at the challenge description. Okay, in the case of reuse of the key, weaknesses are introduced. Knowing something of one of the messages, you can decrypt them without having information about the key. Okay, so XOR is being used. So this is called a crypt drag attack. So MTP is going to help us decipher this. So here's the thing. Where does it tell us if this is supposed to be like a many-time pad attack in MTP? Where's the information that we're supposed to know? Nick CCS has subscribed with for 11 months in a row. Hey, Nick CCS, nice to see you here, and thank you very much for the subscription. Let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up again!
Okay. How's the stream going? Stream's going good. We just need to... I think what we need to do is we need to get the original message here, because I'm pretty sure we're missing something. So we're just gonna get the original translation. So show the original. Okay, so they talk about the crypt drag attack, they talk about MTP, they talk about the XOR operation. They say that this is supposed to be the Vernum cipher that's being used. AVC, hello, nice to see you here. An ad, yeah, there was an ad. The ad should be over now. So is this like not reused over here? So let's see, we'll just spot translate this. Never reuse. Yeah, okay. So here's the thing: if it's supposed to be in like many-time pad attack, where's the previous information? So let's ask our good friend the AI over here, because we don't see any previous information in this challenge. So it says don't reuse the key, but where's the reused key? We only see the unless this output file has both the key and the message in the same thing. Because what this looks like is it just looks... Oh, you know what? So we do... Is this like XOR brute? Let's take a closer look at the MTP Python file. Not that I would be able to make very much sense out of it. Maybe what I need to do is I need to get an example of how to use this thing. Let's see. Who made the Cameron Lonsdale? Cameron Lonsdale MTP example. Since you're teaching people, I have a question. I am thinking of coming back into tech after a decade. Especially cybersec, I don't know. So, what's your AVC? What is your question? Are you looking for education resources? I've got a lot of them. So if you're looking specifically for education resources on different topics, you can take a look at this link over here. Alpha says our production server got infected with a crypto miner. What would be your forensic steps to identify the backdoor which the attacker used? What would be your forensic steps to identify the backdoor which the attacker used? So the backdoor the attacker used. I mean, the first thing you would do is you would probably try to figure out how they got in. So you would do a... This isn't really my area of expertise, but the first thing that I would do is I would try to figure out how the attackers got in, and then take a look at files that have been changed between the last time that you did your backups and when you found the crypto miner. So SysOS Master probably has a better approach. Yeah, a better series of steps to take for this particular attack. Okay, so CLI Py Master, so this is the same repository. Okay, so I'm not really too sure how the MTP program is working. So we can click on these. And it says that the key is probably this. Maybe because it's looking for... So these represent the lines in the file. So they're like 9 lines in the file. So output.txt, they're 9 lines, right? So we've got 9 lines, and they've got what the program is doing is it's trying to do its best to guess at what the key might be. So we got a flag over here. If we're able to identify additional parts of the key, then we could translate the whole message. Okay, so what we need to do is we need to figure out what these words might be. Okay. Can we copy this? So I think you're supposed to do escape, export, and let's see if it wrote out a file. Result JSON over here. Okay, so we're just going to copy the entirety of the message over here, and we're going to feed it into our good friend the AI, and then maybe it can figure out what words are supposed to go in this place. Okay, we'll go over here. And we'll explain we are using the MTP Python tool to decrypt a message. The message is in Italian. Can you make a best guess as to what the blanks in the words are, or in the message, to help us reconstruct the key? Okay. Oh, it's working. Or it's trying to, anyways. Checking the Italian message pattern for possible key fragments. Reconstructing the Italian message for the pattern. So my question is, how did the MTP script manage to assemble what is here, though? This is what I really don't understand. Wow, it's working it's been working for a while on this thing. Okay, so AVC says, I was into cybersecurity back when Cali was backtracked, but things didn't work out. Bad internet, PC, electricity, and people said I was wasting money. I was really good at it, but there wasn't HackerOne or anything, and this is a bit out of your wheelhouse. When I try to read cybersecurity concepts these days, I keep telling myself that I should have figured this out by now. Even though I'm on the first line, every time a bash script fails, I hate OK. I mean, AVC, are you trying to get into... like bug bounty stuff? What's your area? What's the area that you want to specialize in when it comes to cybersecurity? Do you want to do web app security? Do you want to do bug bounty hunting? Do you want to do network security? Let me know. Okay, so what actually happened here? Oh, excellent. I have Utizate confirmed. Let me continue constructing all the lines. Okay, can you continue constructing all the lines then? Okay, so where is this word likely to be? Does bug bounty still work these days? Are all the lowest hanging fruits are gone? I mean, even if the lowest hanging fruit is gone in bug bounty, you can still find yourself like a niche in finding utilizate. You can still find yourself a niche in working in specializing in other types of vulnerabilities. So let me start talking about this. So bug bounty, finding a niche. So there's lots of AI. There's lots of AI in the bounty space. If you want to get into bug bounty, I'd say that what you want to do is you want to specialize in a type of bug that's hard for the automated scanners. That's hard for the automated scanners to find. I'm not exactly sure what that might be. You have to do it for the love of the game. I mean, if you are... The other thing is that if you're not really into cybersecurity, if you're not into web app security, I'd say don't do it. I'd say that you have to like what you do, and don't do cybersecurity if all you're interested in is money. I mean, people say, of course I'm not just interested in money. If your primary motivation is money for getting into cybersecurity, maybe you shouldn't be doing it. Okay, is it possible to make a living using IT skills without permanent job or running your own business? Make a living using IT skills. I mean, you've got to work for somebody. I mean, the other thing you could do is you could do you could do IT education content. That's what I'm doing right now. If you're good at it and you're able to explain the IT concepts in a way that people can understand easily, then maybe you could do IT education stuff. Okay, so let's see. Anything that combines more than one thing is currently hard, and more than two is impossible for the AI agents. Okay, Caprice says, a lot of vibe-coded software has become more prevalent on the web, which means more vulnerabilities. Yeah, the stuff that they're deploying, well, that stuff that is being created by the AI is not necessarily checked super hard for safety first. It's more about just trying to create something that works, especially for people who are not super interested in security, which is most people. Utilizate. Okay, what does this word mean? Probably means like utility, something something. I'm not completely sure. Translate, google.com. We're gonna go from Italian to English. Use. The word use in Italian is utilizzate? Alright. Where was that? Oh, okay. Maybe here? How do you spell that? Huh. Okay, so if we're able to fill in one of these words, we actually get a lot of the message. Okay, and let's see. Sierra says, my friend vibe-coded a web app with an AI chatbot. I asked the chatbot what vulns the site had, and it listed them out for me with CVE links. That's awesome. Depends on the context. Utilizzate is more like to use for if my Italian is good enough. Joseph asks, have you done any bug bounties? And if so, is it better to email? Is it better to email about the vulnerabilities? Reason being, I did just one. I always hear back. I always hear back, but never really heard back on. So let's say HackerOne. And thank you very much for the YouTube subscription, Souls. Thank you. Okay, so have you done bug bounties? I mean, I haven't done bug bounties myself. I hear from other people. I hear from other people about their experiences doing bug bounties. And in bug bounty, there's a lot of... I mean, there's a lot of horror stories about bug bounties because... Let's see. So, bug bounty, horror stories. Horror stories in bug bounty. So stuff like... the bug you submitted was not considered in scope, or the bug that you submitted was a duplicate, or the bug you submitted was not considered important enough. So these all lead you to not having your bug successfully submitted, I guess. Bug bounties are hit and miss. Horror stories, you say? I mean, there's a lot of stories like this. You submit a bug, but somebody else submitted it, so you don't get credit. You submit a bug, but they say that it's not really considered to be in scope for the particular program. You submit a bug, but it's not considered to be a high enough what is the word, impact bug, so that they don't really care. What is the word? So the job of the people who get your bug bounty is to not pay you. Is to not pay you unless absolutely necessary. Not a bug, but a feature, maybe. I mean, the people are running a company and they want to save as much money as possible. So unless you show them that unless you show them a bug that's absolutely going to destroy the is absolutely going to destroy the web app, they're probably disincentivized. The reality of bug bounty in a web shell, in a nutshell. It's one of the things that MS has said before. It's tough. It's tough to... I mean, I think the role of... What is it? The role of the platforms, bug bounty platforms, is to keep the companies honest. Leaked admin credentials, that's what I submitted. Leaked admin credentials, that's what you submitted in your email. So that's the bug that you found. So leaked admin credentials in the web app. I mean, I hope did they not get back to you? Is that it? Because that seems kind of that's not very... That's not a very honest interaction, yeah. Okay, so what other words can we guess? I wish they would of something on HackerOne. let's put it this way, we recently got a whole list of Windows BitLocker POCs because Microsoft didn't want to work with the security researcher regarding payment. That's yeah. I mean, if you're talking about companies that make a very extensive use of AI, Microsoft is one of them. They're trying to get all of their security people to use AI in their workflow right now. What other potential words can you identify in the message? Okay, utilizate. Where was it? They didn't even show me, I guess we need to show the steps. Okay, based on my analysis of the Italian MTP decrypted message patterns, here are the identified words organized by category, confirmed words pattern matched. STO, utilizando. Okay, so it's not utilizate, it's utilizando. Let's go back here. How do you spell the utilizando? Okay, so this makes more sense. We're not getting any weird stuff in here. Okay, AVC says, how do you stay safe while streaming? Leaked email IDs, location on Google search results. I mean, I try to identify where my information could potentially be leaked and not show it on stream. So a lot of the time when I have to search for something on Google, and I think that Google might leak out information about my location or something, I just blank out the browser screen. So I do that search off of the live stream, and then I bring it back if there's no personal information here. Although I have leaked information before, and it's pretty embarrassing each time I do, but I'm trying to keep those to a minimum. Okay, STO, I am, utilizando. So where's STO? Esto utilizando something something. And we just need to finish this to the point where we can get the flag. Okay, continuano. So legarai, you will read legarai. Where can we identify that? Here. Okay. Continuando to continue with something. That makes sense. Line 4. Continuano. Where's that? Okay, SysOS Master says something to do with continue on line 4. Line 4. On Tien. Oh, here it is. Continuano. Continuano? Okay, so we've gotten most of the message now. Line 4, third word. Line 4, third word. Continuano. Okay. Okay. So we're getting closer. Utilizate Serrano will be Sabagliano to mistake. So where's Sabagliano going to be? Here it is. Sabagliano. Okay. Just for fun asks, how to hack third-party apps. Which third-party apps are you talking about? AVC says the worst part about using Google is sometimes during the AI-generated output in the search results, it will randomly say, since you're based in this locality, city, state, this is bad. I mean, it is really bad if you're trying to stay anonymous. Is this like Sudoku? I mean, I wouldn't say it's like Sudoku, but it is kind of like recreating a message. And we're just doing a challenge about one-time pad attacks. And in this case, it's many-time pad attacks. So if you want to take a look and you have an account over at OLIcyber.it, then give it a try. So the problem here is that we're dealing with an Italian message and not an English one. So this has to be problem, right? Problem in Italian and problem in English has got to be the same thing. Yeah, maybe. But we still don't have these letters. So I mean, this has to be an I, right? Il cryptosistema. Oh, this is crypto system, right? So this has got to be an I. Oh, okay, good. Problemo, I think. Problemo? Problemo? So we need to... Okay, we're getting pretty close. It's Brody. Hello, nice to see you here. Okay, we've got an ad on Twitch right now, so we're just gonna take a break and put on some birds. How about these birds? Okay, we'll be back in about 60 seconds. I just need to take a little water break. But enjoy the birds and enjoy the music. Well, yeah, we'll be back in a bit. Okay, so let's get back to the hacking stuff, cryptography in this case. And just for fun says, third-party hacking is easy or not? Is third-party hacking easy? I mean, if hacking were easy, everybody would do it. So is this going to be an O? Okay, so maybe we'll export this again. This can't be an O because this becomes a T in this case. Yeah, that can't be it. So can we take this away somehow? So go back to unknown? No, we can't do it like that. Oh, we can do it like this though. Okay, so we'll feed it back in. No leggerai questa segretisma sima something something. Okay, let's export this again. So export, and then go back and we'll take a look at the JSON file. Okay, locking up. I think I was speaking Spanish, Italian. It's problem. Okay, so let's try this right here. And we'll try asking, so what is the full sentence in Italian likely to be? And then we supply this. Okay, I actually do speak a little bit of Italian, maybe I can help. So this is what we have. This is what we have right now. I guess I'll feed this all into chat. Il crito sistema cesto utilizzando something 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 something. Indestructible? Indestructible. Maybe it's indestructible over here? Maybe. Let's try filling that in. Over here. So B here, and IN I don't know about that. I mean, the rest of this looks okay. Okay, the full sentence in Italian is likely Il crito sistema che sto utilizzando sempre indestruttibile. Indestructible. Is that how you spell it? How do you spell that? E. Okay, yeah, it's what you said, Xiaolao Shu, yeah, for sure. Okay, and what is this word? Sempre, sempre. Whoops. Here. Okay, so we've almost, well, I mean, we've got the entire flag now. We've got the entire flag. We can just try submitting the flag and then see if this is the correct one. So it's, I think they're talking about Stephen Hawking over here. So K-I-N-G. Many-pad nightmare. Okay, so this, I mean, this looks like the correct flag. Alright, so let's export this, and then we can solve the challenge, and then we can move on to the next part of the stream. So I'll come back here, and I'll do my write-up afterwards. Something like the crypto system that is being used is always indestructible. So we'll export this, and then we'll go back. So many time pad nightmare. So this seems like a likely flag. Okay, and we'll submit this here. And it says wrong flag. It says wrong flag. So there's got to be some part of the message that we still don't have right. So nightmare, this is probably going to be an A or a 4. Okay, let's go back in. Yeah, it's probably going to be this. And that's the valid flag. Okay, got like one character wrong somewhere. Leet speak, yeah. All right, we're done. We're done. So we'll do the write-up for this afterwards. We're already kind of behind schedule for our next part of this portion of the stream. So topic 2 is done. Topic 3 is here. So we're doing more cryptography stuff. We're going to be doing an intro to cryptography, and let's go ahead and get that started. We'll put 60 minutes on the clock, and we will begin now. So if you want to join along with us, what you want to do is you want to make an account over at cryptohack.org. So this is a website where we can learn about all sorts of great cryptography stuff. And where are we? Okay, so this is the first session for cryptography. Let's go ahead and get started. Yep, we got the clock going right now. So this is HackerFrogs AfterSchool, encoding with cryptohack.org. So the first thing we're going to be learning is not actual cryptography. We're going to be talking about encoding methods, because encoding methods and cryptography are kind of similar in concept, but the intent is different. Welcome to HackerFrogs AfterSchool. HackerFrogs AfterSchool is a cybersecurity program for learning beginner cybersecurity skills across a wide variety of subjects. This workshop is the first lesson for cryptography. In this first lesson, we'll be easing into simple cryptographic concepts through learning about encoding. What is encoding? Encoding refers to the process of converting data from one form to another, often for the purpose of efficient storage, transmission, or representation. So for example, the words hello in ASCII encoding are represented by these binary digits over here. So this binary number is the letter H, and the letter E is this one, LLO, and what the computer does is it turns these numbers into these characters when they're encoded using the ASCII method. Is HackerFrogs free? Yeah, I mean, I'm here presenting HackerFrogs for free on Twitch and on YouTube. So it's free, yeah. So for example, before the word hello can appear on the computer screen, it needs to be encoded into ASCII characters from the binary numbers that computers use. Do you have a link to this PDF? If you want the link to this PDF, I can give it to you, sure. I think this is it right here on my GitHub. Okay, although encoding transforms data from one form to another, it is not considered cryptography because the purpose of encoding isn't to keep data secret. So the big difference between encoding and encryption is that one is meant to keep something secret and one is not. So nonetheless, encoding is a good introduction to cryptography because it introduces us to transforming data according to different systems and rules. So the platform we're going to be using to learn about cryptography is called CryptoHack. We'll be learning encoding basics by working through the intro course on the CryptoHack platform, which is a great free platform for learning cryptography concepts. So if you don't already have an account there, you can sign up at the following link. So hit cryptohack.org/register, and I think I can copy this. Hold on. Let me get that link. Just a second. Cryptohack.org register. Yeah, so if you don't have an account, register over here. Oh, and they want you to solve this Roman Emperor cipher. Enter the forward solution here. I mean, to sign up for the website, you need to solve the cipher over here. So this is the Caesar cipher. And how would you solve that? So this is how you do it. So there's a bunch of like Caesar cipher deciphering websites out there. And what you do is you would put in the ciphertext over here on this website. You could use TR if you wanted to. I mean, for convenience, it's a lot easier to recommend some sort of web tool. So what you would want to do is you would take the ciphertext and put it in here, and you would slowly move the shift until you get a message, like recognizable English words on the other side. So just keep on shifting. So this will take like a maximum of 13 shifts. Okay, so we do a shift of 27 in this case, and we're able to get these words over here. I'm pretty sure that the when you register the words or the actual message here, it's going to be randomized each time. You could do it by hand if you really wanted to. Anyways, let's continue on with the lesson. Okay, you might need this website to complete the registration, so crypty.com/pyt/CaesarCipher. So after you've logged in, navigate to this link to start the course. So it's cryptohack.org courses, intro, and then course details. So over here, after you logged in, under courses, you're going to see the Introduction to Crypto Hack course. So this is the one you want to access. AVC says, do you have a schedule for when you stream? Yeah, we keep our schedule over at our Reddit over here, and we also have like a Discord as well. So our schedule is posted to both of those platforms. Okay. Okay, so what you want to do is you want to sign up for this course. And what is the overview here? So it says this starter course will get you up and running with CryptoHack. You'll learn to encode and decode data types that are commonly used in cryptography. Then you'll get comfortable with the XOR operation, which is at the center of symmetric cryptography. Finally, the course ends with some fun XOR puzzles to test what you've learned. CryptoHack is free and free to play and browse. Okay, and what we're going to do is we're going to start the course. Click on Start Course, and then this is the first challenge. So the first challenge over here doesn't really have anything to do with cryptography, but it does explain how the platform works. So this challenge is called Finding Flags. Over here. It says each challenge is designed to help introduce you to a new piece of cryptography. Solving a challenge will require you to find a flag. These flags are usually in the format crypto, and then between some curly braces, some information here. For example, your first flag. You found one. Hey, that's awesome. The flag format helps you verify that you found one correct solution. Okay, try submitting this flag into the form below to solve your first challenge. So because I've already solved this challenge, we don't have a submission field. But if you haven't solved it, what you want to do is you want to copy this flag here and then paste it into the flag submission field to complete the challenge. Okay, so that's just the first challenge. We're going to move on to the next one after this. Okay, then click on Next. And then the next challenge here. So the next challenge here is called Great Snakes. Modern cryptography involves code, and code involves coding. CryptoHack provides a good opportunity to sharpen your skills. Of all the modern programming languages, Python 3 stands out as ideal for quickly writing cryptographic scripts and attacks. For more information about why we think Python is so great at this, please read the FAQ. Run the attached Python script, and it will output your flag. Okay? So what we need to learn here is we just need to learn how to run a Python script. It's not super difficult. And click on the file, and that should download the Python script to your system. Okay, you can click and open it up. So what's important here is not so much the Python script itself, is that we're trying to establish that you can run a Python script. Okay, I'll put the Python script in a paste, just in case you don't have access to the Crypto Hack course. Okay, we'll paste in the script. Did I not copy it? Looks like I didn't copy it. Just a second, everybody. Let me just copy that file over here. What was it called? GreatSnakes.py, right, okay. So it's in my downloads directory. That's a funny file extension. Okay. So let me go ahead and provide this script to everybody who wants it. Okay, so if you want to get access to the script yourself, there it is. And if you don't have a machine that has access to Python, you can use this machine over here, the JS Linux machine. So JS Linux is a web accessible version of Linux that you can use to run your Python scripts. Over here. So what you would do is you would create the Python script in here. So use like the nano text editor for GreatSnakes.py, and then paste in the Python code. And just grab that Python code. The unfortunate thing about these web accessible like Linux terminals is that they usually are kind of slow. Okay, so we would paste in your script and then you would save it out. So Control X, Y, Enter, and then you would run the script with this command over here. So it's Python GreatSnakes.py, and that'll output your flag. Okay, I mean, I'm trying to... Python 2. Python 2? We're trying to run Python 3. I'm trying to be as positive a person as I can while I'm teaching people here. Why doesn't... Which Python 3? So there is Python 3. Run it with GreatSnakes.py. Why is it giving me this error message? It says you're running Python 2. Why does it say that? Using too old a Python won't work. Okay, so Python 3 version 3.9. It should work. Are you missing part of the script? I might be. I might not have copied everything. Okay, let me do that again. Although I think I got everything. So let's see. So user bin and vn Python 3, O and ords. Yeah, I'm pretty sure I've got the whole thing. I mean, if I run it on my Kali Linux box, it should work. Python. Yeah. So if I run it on my Kali box, it gives me the flag. So crypto zen of Python. Did it all get in the box though? Good question. Let's go back to the JS Linux. Okay. Yeah. I mean, I don't see anything wrong here. So import sys.versioninfo.major equals 2. There might be something wrong with the Python on this box. It cut off the lines, did it? Oh, it did. Okay. Yeah, okay. Alright. My bad, everybody. So now we get the flag. So it's crypto zen of Python. It has to be in the machine from the site. I mean, that's not... It's just that the copy-paste kind of went weird. Maybe somewhere between... The copy-paste didn't work for some reason. It might be a problem with the web accessible version of Linux. But we got the flag. So what you would do is highlight the flag and then copy it. Then go back to the CryptoHack website, and then there should be a section where you can submit your flag, paste it in, click on submit. So, but we've already completed this one. So, I mean, we still haven't learned anything about encoding yet. Anyways, let's continue. Okay, so this is our actual first challenge that involves encoding, and I think I might have written something in the presentation file about this. So we're talking about ASCII encoding first. So the first system of encoding that we're going to look at is ASCII, which is a common text encoding system which assigns numerical values to letters, numbers, and symbols. So for example, the lowercase h in ASCII encoding, in binary, it's this number. In hexadecimal numbers, it's this number. And in decimal, it's this number. So these all mean the letter H in ASCII encoding. ASCII encoding can use either binary or hexadecimal or decimal. ASCII can take its input in different numerical formats, such as binary, hexadecimal, or decimal. So the original ASCII characters can be found in this table over here, and I'm pretty sure I got this table from, like, Wikipedia. So this illustrates to us how the conversion is done in ASCII. And if you want to take a look at the Wikipedia article, it's over here. Let's see. I think there should be like a big ASCII table in this article. No, I guess not. Okay. ASCII table. This is the one that I'm referencing over here. Let's put it in a new tab. So the table is a pretty good man page about it too. That's also true. Hope your birds have been alright. I know that you've been feeding them nicely. I mean, I try. Okay, so you're going to notice that there's decimal and hexadecimal here, and then there's the actual character that is being encoded. So we got all of our common symbols over here, we've got our numbers, we've got more symbols, and then all the capital letters and all the lowercase letters over here. So the original ASCII encoding table only goes up till 128 characters. So starting from 0 and ending at 127. And we're missing octal, that's true. Okay, Nitro Based, hello, nice to see you here. Okay, let's continue on to the lesson. So we're going to be learning ASCII with CryptoHack over here. This is the link. Okay, so the challenge here says ASCII is a 7-bit encoding standard which allows the representation of text using the integers 0 to 127. Using the below integer array, convert the numbers to their corresponding ASCII characters to obtain a flag. And it says over here, in Python, the CHR function can be used to convert an ASCII ordinal number to a character, and the ORD function does the opposite. So this is what we have over here. Okay, I'm learning JavaScript for web hacking. Is it a good idea? I think knowing JavaScript will help you out, because it'll help you understand how websites work and what kind of code is involved. Okay, so here we're talking about Python. So what we can do is we can create a little Python script that converts these numbers into ASCII. So I think maybe the easier way to do this is not to use a Linux virtual machine, but to use like a web app. So something like Python Online or Online Python. Let me see if I can find it. So onlinepython.com. So this is a website where you can play around with different... This is where you can play around with some Python code. So what you want to do, if you're using this website, is you want to get rid of the code that's already in the main.py window. And what we're gonna do is go back to the challenge. We're gonna copy this, okay? And then we're gonna go over to the Online Python window. Okay, and then we're going to paste in the list. So this is actually already formatted in a way that Python likes. So this is a list of numbers. So let's see. We're going to call this ASCII list. So ASCII list equals this thing, this big list of numbers. And all we need to do is we need to create, looks like your ad blocker is on. I don't have an ad blocker on this machine. I don't know why you think there is. Anyways, so what we would do is we would translate these. So let's see, maybe like for I in ASCII list, we would do something. We would run... We need to ad block. Yeah, we need to ad block this. I mean, they're trying to make money. The people who made this application, they're trying to make money. I don't blame them for trying to. And I think we need to run the CHR function. So run CHR on I. And I guess we can also create like a flag. So flag equals empty string. And then we can add whatever character is already, whatever character we translate, we can add it to the flag string over here. So CHRI, and I guess we can flag equals flag plus CHRI. I wonder if this works, because strings can be kind of finicky in Python. And then at the end of the script, we just print the flag. Okay, and let's see if this works. Run. And then we get the flag. That's great. Okay, so what happened here? So we ran a little for loop over here, over the list. So in the ASCII list, it does 99, and then 114, and then 121. Each time it runs over each one of these characters, it runs the character function on it, which converts it from a number to an ASCII character, and then it adds it to the flag string. And Coding with Strangers has rated my channel with a party of 4. Thank you very much. Coding with Strangers, and let's give Coding with Strangers a shout out here. There you go. And got a jet, but much love. Jet away. Jet away. See you later, Coding with Strangers. And thank you for coming by. Okay, so for each one of these things in the list, we populate a flag string with the ASCII encoded, or the ASCII, with the ASCII encoded version of this number, and then we print out the full flag at the end. So we get this flag right here called crypto ASCII printable. So we just need to copy the flag, then go over to the challenge, and then paste in the flag over here. So we've already solved this challenge, so we don't really need to do any more of that. Okay, and then we'll move on to the next challenge. So that's ASCII encoding. So there's a bunch of, well, there's a couple of other encoding standards that we're going to be covering today. So that was ASCII. So the next one is hexadecimal encoding. Okay, and before we get going with that, let's talk about this. So hexadecimal numbers. Hexadecimal is a system of counting in base 16, whereas our normal counting system is called decimal and is base 10. So here's what the numbers 0 to 16 look like in hexadecimal. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and instead of the number 10, we have the letter A. So A is 10, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F, and 16 is 10. It's not exotic. Is it not exotic enough? Okay. So these are hexadecimal numbers. So you're going to see hexadecimal numbers when you deal with computers, when you deal with computer science, when you know, it's a very common thing to see, hexadecimal numbers. So another thing that we need to understand about hexadecimal numbers is that one reason why hexadecimal representation is used in computing is because it allows 8 digits, or it allows 8-digit binary numbers to be represented with 2 digits. So 8-digit binary numbers, they can be converted into 2-digit hexadecimal numbers quite easily, and this helps us save room. So if we wanted to represent the same information using decimal, to get all the way to 255, for example, we would have to use 3 digits. And when you're dealing with computers, we want to be as efficient as possible. Okay, and another thing we're going to be talking about is converting hexadecimal to ASCII. So it's also very convenient to represent ASCII characters with hex or hexadecimal because it allows non-printable ASCII characters to be represented, non-ASCII characters to be represented with hexadecimal. So we're going to be learning about hexadecimal with CryptoHack. RestreamBot is a person because the number is in the name. No. RestreamBot just means that it's a message coming from the other platform. So messages from Twitch will appear as a RestreamBot on YouTube and vice versa. Okay, so let's learn more about hexadecimal encoding by working through a challenge on CryptoHack. Navigate to the following URL over here. Okay, so it says here, when we encrypt something, the resulting ciphertext commonly has bytes, which are not printable ASCII characters. If we want to share our encrypted data, it's common to encode into something more user-friendly and portable across different systems. Hexadecimal can be used in such a way to represent ASCII strings. First, each letter is converted to an ordinal number according to the ASCII table. Then the decimal numbers are converted to base 16 numbers, otherwise known as hexadecimal, and then the numbers can be combined together into one long hex string. Included below is a flag encoded as a hex string. Decode this back into bytes to get the flag. So we've got this really long, well, it's not super long, but it's kind of long. It's a string of hexadecimal numbers. Cypher says, CTFs are getting me near the point where I can read them just by looking. Will this help me in my career, or are they just for CTFs? I mean, you're gonna see hexadecimal ASCII representation in a lot of places in computing. So I wouldn't say that it's just for CTFs. Okay, so included below is a flag encoded as hex string. Decode this back into bytes to get the flag. So what we need to do is we need to take these characters and we need to convert these into ASCII. So we could do this a couple of different ways, and I'll show you one convenient way right now. So we could use a website called Cyberchef. So it's cyberchef.io, and we would paste this into the input field over here. So Cyberchef lets you do a bunch of different transformations on data. So in the input field, we've got our hexadecimal string, and then you could do an operation on it from hex. So from hexadecimal to ASCII. So paste it in here. And then we see this flag over here. Crypto, you'll be working with hex strings a lot. So usually there's more than one way to get something done in data, well, when we're dealing with different types of data. So this was solving it using Cyberchef, and I think you should be able to see exactly what I'm seeing if you use this link over here. Okay, the other way we could do this is we could do the same operation using Python. So over here, we're going to create something called our ASCII. We're just going to call this our hex string. So hex string equals a string with all of, oops, not supposed to be doing this. So hex string is this thing over here. Okay, and in the challenge they told us about a certain function in Python. So it says, in Python, the bytes.fromHex function can be used to convert hex to bytes. The .hex instance method can be called on byte strings to get the hex representation. So, interesting. Okay, let me try this out. So, supposedly the .hex method can be used to get hexadecimal representation. Let's see if this works. So if we got, so regular string equals HackerFrogs like and subscribe. Okay, and then what we could do is we could do regular string .hex, and that would convert it over to hexadecimal numbers. So let's go ahead and print that out. Okay, run that. And then str attribute has no attribute .hex. Did I do that wrong? The .hex instance method can be called on byte strings. Oh, okay, you need to run it on a byte object. Okay, so we can solve that pretty easily by including b for bytes in front of our string over here, and then run it again. And that converts this string over into a hexadecimal string over here. Okay, just for fun, let's try decoding this. So back at CyberChef, we'll get rid of the input we have here, and then we paste in the string that we just created, and then we get the output HackerFrogs like and subscribe. Awesome. I'll go down in history as the first person to own every cat picture ever uploaded online. I mean, the thing is that the number of cat pictures being uploaded online increases every day. It probably increases like every hour or every minute. So it's kind of like impossible to own all that, to own every cat picture. Unless you cut it off at a certain point. Okay, so what we want to do here is... I guess what we need to do here is we need to turn the hex string into bytes. So we need to put the B in front of here to make this, Oh, no, that's not it. Okay, we're dealing with a different function. So in Python, the bytes from hex function can be used to convert hex to bytes. Okay, so what we would do is we would run bytes from hex on the string we create over here. So print bytes.fromHex on hex string. Okay. Why is it taking so long to run? Okay, let's copy this, and then we'll just reload the page. And we'll run the program again. Why isn't it running? Let's just try doing this on our own terminal. Okay, so it does work. So it gives us bytes. Crypto, you will be working with hex strings a lot. So what you would do is you would copy this. So if there's anything you don't quite understand about what's going on, the stuff that we're doing, let us know in the chat and we'll try to explain as best we can what's going on. Okay, so copy the flag, then go back to CryptoHack, and then paste in the flag in the challenge description over here. We've already solved it, so we can't do it again, but you should be able to paste in the flag at the bottom of the challenge and click on Submit, and then we can move on to the next challenge. So the next challenge is dealing with base 64. So base 64 is another very common encoding method that you see especially in CTF challenges. Well, let's talk about what this is. Okay, so we're talking about base 64 encoding, and base 64 is a system which converts data bytes into strings made up of characters in the base 64 character set. So the base 64 character set, think of it like an alphabet. So the alphabet of base 64, or a set in base 64, is made up of uppercase characters, lowercase characters, numbers, and the plus and the slash sign. So if you see a string that is made up of these kind of characters, you might guess that it is base 64 encoded. Okay, so here's an example of encoding a string using base 64. Notice the presence of equal signs at the end of the base 64 encoded string. So if we echo out HackerFrogs and then base 64 encode it, it becomes this string over here. So we can demonstrate pretty quickly. Over here we can echo out HackerFrogs like and subscribe. and then pipe it into the base64 command, which converts this into a base64 string. So if we see a string that is uppercase and lowercase letters, it might be base64 encoded data. If we echo out this same method, or this same string, and we base64 decode it, then we can get back the original message. Okay, and so base64 encoded strings will always consist of a number of characters that are divisible by the number 4. There is Nyan Cat. Thank you very much, SysOS Master. Okay, so if the case is that the encoded string does not have a number of characters that is divisible by 4, then they'll add in these equal signs over here to be placed at the end of the string until it is the correct length. Okay, so we're going to be learning about base64 with crypto hack over here at the next challenge. So here's the link. Alright, so let's read about this briefly. So this is the base64 challenge. Another common encoding scheme is base64, which allows us to represent binary data as an ASCII string using an alphabet of 64 characters. One character of a base64 string encodes 6 binary digits, or bits, so that 4 characters of base64 encode 3 8-bit bytes. Base64 is most commonly used online, so binary data such as images can be easily included into HTML or CSS files. Padding, padding symbols. It should say symbols. Okay. So what they want us to do in this challenge is take the below hex string and decode it into bytes, and then encode it into base64. Okay, decode it into bytes, and then encode it into base64. So this string right here. So if you want to give this a try yourself, what we want to do is we want to turn into bytes first, because what these are hexadecimal characters. So this is a hex string. So what can we do with this hex string? We know that in CyberChef we can start decoding it from hex over here. And what we can do is we can also add another operation, which is base64 decode. So from base64, and then drag it into the recipe bar over here below from hex. Maybe we're supposed to encode it to base64. It's supposed to be to base64. Never mind. Just a second. Okay, so the operation is going to be to base64. Okay. And we get this flag over here, crypto base64 encoding is web safe. Great. Okay, so this is one method of solving this challenge. If you want to see this exact thing in CyberChef, you can follow this link. Okay, the other method of solving this challenge is using Python, which is what they want us to do. So it says in Python, after importing the base64 module with import base64, you can use the base64.b64 encode function. Remember to decode the hex first, as the challenge description states. Another one is magic in CyberChef. I mean, magic is... It's probably better to teach people the exact operations instead of telling them to use magic. Okay, so we're gonna take our hexadecimal string and copy it. Then we're going to do some Python coding. So the hex string here, we're gonna paste it in. And then we're going to define something else. So hex bytes is going to be bytes.from hex on hex string. So we turn the string into bytes here, and then our base64 string is going to be a transformation on that. Magic is also good to know about. True, it is. It is a good thing to know about, but maybe not right now. Okay, so the last thing we're going to do is import base64, because base64 is a module, and Python can't run base64 unless we import that module. So we'll do that up here. And then we'll run the base64 encode function. So base64.b64 encode the hex bytes. Okay, and then we'll print the base64 string. Okay, and then run that. And then we get this string over here. Crypto base64 encoding is web safe. This is the flag for this challenge. So we just need to copy it. And then go over to the challenge. At the bottom, you should be able to submit the flag and then click on the submit button to finish the challenge. But since we've already solved this, we can't do that. So we'll move on to the next challenge. Okay, so this next challenge is called bytes and big integers. Let's talk a little bit about this. Oh, that's the summary. Okay, so let me just do a double check to see how many of these challenges we're doing today. We do finding flags, write snakes, crypto ASCII. If you want to take a look at like a step-by-step method of solving each one of these challenges, you can take a look over at this GitHub link over here. Oh, apparently this is supposed to be the last challenge we're doing today. I mean, we've got a few minutes left. We should be able to do some more of these, do some more of this right now, unless it's supposed to be for the next lesson. Just a minute, everybody. I need to take a look at my lesson plan. Okay, I think we can do the next challenges over here. Okay, so this is the bytes and big integers challenge. So it says crypto systems like RSA work on numbers, but messages are made up of characters. How should we convert our messages into numbers so that mathematical operations can be applied? The most common way is to take the ordinal bytes of the message, convert them to hexadecimal, and then concatenate. This can be interpreted as a base64 hexadecimal number, and also represented in base 10 decimal. So let's see. To illustrate, we've got our message. It's hello. Okay, so the ASCII bytes for these 5 letters would be 72, 69, 76, 76, 79. So this is decimal representation. So as hexadecimal bytes, this would be hex 48, hex 45, hex 4C, hex 4C, hex 4F. 16, not 64. Where did I say 16? Where did I say 64? Sorry if I misspoke. Okay, so in base 16, we would take these hexadecimal digits and we would concatenate them all together. So 48 would go with next to 45 and then 4C, like this over here. Okay, and if we were to do base 10, I guess we would take this hexadecimal number and then we would convert it over to decimal numbers. So let me see if this works. So if we take this number and then we want to represent it in base 10, I'd probably want to convert this using like a web app or something. Hex to decimal. Oh, maybe. Okay, so hexadecimal to decimal, put this number in. So this is the decimal digit over here. Okay, so it's 31, ends with 87. Thank you very much for subscribing on YouTube, Julian. Thank you. And HexPsycho just rated the channel with 6 viewers. Welcome in, HexPsycho viewers. Let's give HexPsycho a shout out. And what were you up to on your channel, HexPsycho? Let me know. Welcome in, Raiders. My name is The Shy Hat. I do cybersecurity content on Twitch and on YouTube. And I'm currently doing a lesson on cryptography. We're currently doing some exercises from CryptoHack. This one in particular right now. Okay, it says Python's PyCryptogram library implements this with methods such as bytes to long and long to bytes. You will first have to install PyCryptodome and import it from crypto.util import. And then convert the integer back into a message. So this looks like a decimal number. So this big decimal number has been converted. We need to convert it into hexadecimal. And then from hexadecimal, we need to convert it into ASCII. Okay, HexPsycho says, we're dead Sendai from Hack the Box and AD Box. Oh, awesome. Okay, everybody, we're going to take a little break because ads are running on Twitch. So what we're going to do is we're going to put on some birds. And then we're going to take a little water break. We'll be back in about 60 seconds, but enjoy the birds and enjoy the music. Okay, so I guess this guy's just been hanging out. Sometimes the birds land on the bird feeder and they're not really eating. They just want to watch me from the bird feeder. It's kind of weird. Anyways, we'll put the birds away and we'll get back to the hacking. It's Steve. He likes to hang. He's a hangout Steve. Sure. So, I mean, I guess if we wanted to convert this integer back into a message, we could probably do it with CyberChef. Let's see, Cloudflare, lava lamps versus birds. Which one's more random? Random? I mean, it's hard to say. Okay, so if we wanted to convert this using CyberChef, we could paste this in, and then we can convert this from, or convert it to hexadecimal. So 2 hexadecimal, that's one operation. 2 hex. Okay, and then, so these are the hexadecimal digits from this decimal number, and then we would convert from hexadecimal to ASCII. So 2 hex and then from hex. Oh, it's not quite what I expected. So, I mean, I guess these are opposite operations. Okay. So we take these. So the delimiter, let's get rid of the delimiter here. So no delimiter. And then like 2 ASCII. No, this is still like from hex, right? There's got to be something I've gotten wrong here. So we convert it into hexadecimal digits, and then we want to convert the hexadecimal digits to ASCII characters. But I mean, I know that I can do this in in Python. So in Python, let's just grab the big number. Okay, so this is just a big number. Big number equals this number, right? And then what we need to do is we need to convert this into hexadecimal. What do they want us to do? So convert this back into a message. So PyCryptodome. So crypto.util.numbers.import, we do long to bytes. But I'm pretty sure PyCryptodome is not installed on the on this online thing. Let's see. I mean, we can give it a try. So crypto, what was it? From this thing, import all of these things. We'll give it a try in the window. It'll probably complain that the module doesn't exist. First of all, let's just try to print out the big number. Okay, run this. And then, yeah, there's no... Try installing this module in our pyodide environment. And thank you very much for becoming a HackerFrog member, Christian Rink. Much appreciated. Thank you. And let's give you a fun video redeem. How about some Jurassic Park?
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so PyCryptodome, we could probably install it on our Kali Linux machine over here. Let me check to see if it's installed already. So Python import. What is the name of it? Import crypto. Okay, there's no module called crypto here, so I guess it's not installed. So we're just going to need to install it ourselves. Where's my virtual environment? Here it is. Okay, exit. We'll export this first, and then we'll exit. Okay, so pip install crypto. And now we should be able to use that module. So Python import crypto. No module named crypto. Maybe I'm using the wrong thing. From crypto, maybe the module is called crypto.util.number. Yeah, okay. So let's exit. I'm just going to do a quick search on how to install this darn thing. Let's see, Python install PyCryptodome. Okay, so pip install pycryptodome. Is it that easy? I guess I was installing the wrong thing. Okay. Oh, it was already installed. Silly me. Okay, let's do that. Let's see. Big number.py. Oh, what's wrong with my terminal? What's wrong with my terminal? Just a second, everybody. I'm gonna use another terminal. It's poisoned. Yeah, has to be. Okay, install pycrypt. Well, okay, let's run the thing from here. Reset it. Okay, what they want us to do is they want us to... Let's just try running this. No module called crypto. Yeah, it this does look pretty funky. Reset. Okay. And then we run Python big number. Okay. So it looks like we've got it installed here. So we just need to do long to bytes on this. So we'll call this big bytes. Big bytes equals long, what is it called? Long to bytes on something. So long to bytes on big number. So that'll convert. This will convert this really big number over to bytes. So we'll try printing out these big bytes. And then this is what we get. Okay, so crypto encoding all the way down, so this is our flag. So we'll copy this, we'll go over to... So I guess what the... So long to bytes converts a very long, well, an integer, any integer, and then it converts it into hexadecimal bytes, which can be, well, which if they're actually printable ASCII characters, will represent them as printable ASCII characters. Okay. Anyways, let's do our last activity for the day. But before we do that, let's go ahead and finish up the lesson. So let's review the cryptography concepts we learned in this workshop. Encoding. So what is encoding? Encoding refers to the process of converting data from one form to another, often for the purpose of efficient storage, transmission, or representation. ASCII encoding is a common text encoding system which assigns numerical values to letters, numbers, and symbols. Hexadecimal conversion is when hexadecimal numbers are used to represent ASCII characters, and conversion between hex and ASCII is a form of encoding. Base 64 encoding is a method of converting data bytes into alphanumeric strings and is often featured in CTF challenges. What's next? In the next HackerFrogs AfterSchool cryptography workshop, we'll begin our look at classical encryption methods, which are often featured in cybersecurity CTF competitions. So if you know who this is a major figure in the type of encryption that we're going to be talking about next time. All right. So let's go ahead and move on to the next portion of today's stream. Let me just close out some of these windows we're not using right now, because I've got a lot of browser tabs open, which kind of bugs me. Christian Rink says, as a data scientist, freaking Caesar, is there a reason why you don't use an interactive Python console like IPython? I mean, I don't do enough coding so that I need an IDE for my large code bases. Everything that I deal with is usually under 100 lines long, so I don't find that I really need an IDE to handle it. Okay, let's go ahead and start our challenge. So we're doing topic number 4, and we'll work on topic number 4 for about 2 hours. Hopefully we might be able to finish in 2 hours. It may take 3, not sure, but we'll put 120 minutes on the clock, and we'll see what happens after that time has elapsed. It's not talking about an IDE, interactive Python console like IPython. Oh, IPython. I mean, I don't think I know what IPython is. Interactive Python console. Let's see. What is IPython? Python I. Okay, Python and IPython. Python is a programming language itself, while IPython is a powerful, enhanced interactive shell designed to run Python code more effectively. Okay. But, okay, what we're going to be doing next is we're going to be doing Windows Active Directory hacking challenge from HackSmarter. So this is a free module. If you have an account over at HackSmarter, you should be able to access this particular challenge called MartiniAD for free. Okay, and so this is a Windows hacking challenge. We're going to try to use our Windows hacking abilities to finish this particular module. I'm not sure if I'm going to be able to do it today because I haven't hacked Windows in a few months, and I kind of forget all of the regular, what are they called? The regular methodology that is used to hack against a Windows Active Directory. But we'll try to remember and knock off some of the rust. Okay, so what do we have over here? So the objective. So we got an objective, we got details. So an adult beverage company, Martini Bars, recently had a corporate breach, and their compliance and risk team dictates that they perform a penetration test at one of their branch offices. The HackSmarter team has been authorized to perform an internal black box pen test. You just finished this one, Pretzel Pete. Oh, that's awesome. Okay, Pretzel Pete says, I was wondering if anybody... Netcat on Linux VM? What are we talking about, Pretzel Pete? Could you elaborate? Okay, so in initial access, the client has provided you with a VPN to their internal network, but no credentials. So I guess what we need to do is we need to get credentials to the Active Directory first. And what we need to do is we need to launch the machine. Launch the machine and then connect to it. Netcat doesn't work on my Kali VM. My Netcat doesn't work on the Kali VM. I mean, it really depends on which version of Kali you're using. So, I mean, I haven't really updated my Kali in over a year, so I might not be using the same version of Kali that you are. So when I do, like, uname-a, it says that I'm running 6.12.38, and your version of Kali might not be the same one. I'm trying to catch a shell with Netcat, but it doesn't work. You could try catching a shell with some other program instead. I recommend installing Penelope. It's what everybody's it's what everybody's hyping up these days. So let me see if I can and get you a link. Penelope shell handler. This one over here. So give this a look. Penelope is amazing. It gives you the commands to run on the victim. It even gives you the I mean, I haven't used many of the capabilities of Penelope HexPsycho. I've mainly been using it as a more stable netcat shell. Okay, so we're now connected to the machine is on, and we've got an IP address. So the first thing we need to do is we need to download the VPN to get access to the HackSmarter internal network. So we'll click on that. Challenge Lab MartiniAD VPN. Great. We're just going to copy it over to our VPN keys directory here. What is it called? Challenge Lab Martin. Challenge Lab Martin. Huh. Okay, and then from there, HexEcho says it can also catch multiple shells in the same port. Oh, really? With that, I'm off to sleep. Have fun with Martini. Thank you. And yeah, have a good rest, HexPsycho. Thank you very much for the raid. Christian Ring says, with IPython, one does not write a full script and then execute it. We write it line by line. It gets executed interactively. That's where the import error would have been solved easier. Oh, I mean, when you're talking about like interactive Python shell, you're talking about this, right? I mean, this is an interactive Python shell, that's true. But sometimes, I mean, yeah, I guess sometimes it is a lot easier to just work inside the Python shell instead of writing out a script and then running it all at once. Okay, so we've downloaded the VPN keys. So from here, what we need to do is we need to run OpenVPN to access the internal network. And this should be the key. So after this, we should have access to the machine. So we have a ton0 interface, which means we're probably connected via OpenVPN. We also have like an IP address on this network as well. What we want to do is we want to try pinging this machine to make sure that we have access to it. But because this is a Windows machine, there is a chance that we don't actually get ping responses, but in this case we do. Okay, this is good. So from here, we're just going to run an Nmap scan and try to figure out which ports are open on this particular machine. I think this is all we need to do for Nmap. Okay, thank you very much for following on Twitch, Zero Narrative. Much appreciated. Okay, so when we run Nmap, it tells us which ports are open on the remote server, and what we need to do here is we need to keep on hacking against this remote server until we get super user access. We discover a bunch of ports that are associated with Windows, and in particular like Windows Active Directory domain controllers. So ports like 53, ports like 139, 135, and 445. And we're probably going to discover like port 88 and maybe whatever port is the WinRM port. I kind of forget what it is right now. So on Windows machines, you're also going to find a bunch of ports on the 40,000 range that are used for different types of RPC. So with all that said and done, 3389. I'm pretty sure this is this might be like the database service. Anyways, at the end of the nmap scan, it'll tell us what services it thinks is running on all these ports. And immediately, what we can try to do is we can try to do some enumeration of the SMB protocol. So the SMB protocol is port 139 and port 445. RDP, oh, okay. Remote desktop protocol is 3389. Thank you very much for letting me know about that. EPO? Or epoxia? Not too sure. Okay, so as far as SMB is concerned, we can run a very common tool called netexec. And what we're going to do is we're going to run some very basic scans with netexec first to try to figure out if there are null sessions enabled on the server. So what IP address was that? Sick in the mind, nice to see you here. You said come out of lurking for the past 30 or 40 minutes. Well, I mean, we're talking about stuff that that you like to do, hacking Windows targets. Okay, dry.martini.bars. So this is the domain that we're dealing with. We probably want to add this to our etc host file so that we can resolve this domain correctly.
Mr. Hackman, please be excused from class.
Well, Carl,
Yes.
you hear me? You go to
Hack.
You go to
Hack.
you.
Have a great day.
Hope you're having a great day, April. Thank you very much for redeeming the go to hack. Redeem, thank you. Okay, so we're just gonna create another terminal here. We'll call this our regular text editor, and then we'll give it a fancy color. How about some blue? We'll use this to edit our etc host file. And we're gonna add dry.martini.bars and associate it with this IP address. This one. Okay, so that means we can correctly resolve dry.martini.bars to this IP address. So we'll save that out. And we'll go back to netexec. So it looks like we might be able to do some enumeration with a null session, no username and no password. We get some information from the scan. It says that this is when running Windows 11, specifically Server 2025, this build right here. The name of the machine is DC01, which leads us to believe that this is the domain controller for the Active Directory. And let's see what else we received. Okay, so we got open port 88. So open port 88 means it's Kerberos, and we might be able to do some enumeration on Kerberos as well. So in the meantime, we can try to see if we can get some file shares. And it gives us file shares. This is, well, I mean, we know these file shares exist, but we don't actually have permissions on them. So we don't have read permissions, we don't have write permissions, but we know these file shares exist. So the non-standard file share that we're dealing with in this case is notes. So we probably want to get into the notes file share at some point and take a look at what's in there. In the meantime, we can probably try to see if we can get a list of users from SMB. No, it doesn't let us see the list of users. We could also try the rid-brood method. Okay, and let's see. A process has requested access to an object but has not been granted those access rights. So we're not able to do this with our current account, which is zero, which is no account at all. We could also see if there is like a guest account enabled. So user guest, password none. Usually this account is disabled. So I mean, it doesn't really give us any response here. So because it doesn't give us any response, it might be that this account doesn't exist. Huh. Oh, wow. So we are able to see all the users here. Okay, so we've got a number of regular users and a bunch of like groups and stuff like that. So we don't need to go and, what is the word? We don't need to brute force the names of the users. We've got them over here. Okay, so we need to create a user list out of this. I'm just going to copy it. And we'll create a file called, let's do that over here in our research tab. We'll call this users raw. Paste this in. Okay, and what we want to do is we just want to grab these usernames over here. So DNS admins, DNS update proxy. Oh, these are groups. I guess we don't really want the groups. We just want the regular users. Let me go in there and delete those lines. Okay. Okay, and then we're going to do our Linux foo to grab just these usernames. Okay, there's a break on Twitch right now, so we're just going to take a break and watch the birds for about a minute while I have a little bit of water. How about these birds? Where's our friend the woodpecker? Here we go. Okay, we'll be back in about 40 seconds. Just need a little water break. So this handsome bird right here, this is a northern flicker woodpecker. It's a male woodpecker because the males of this particular woodpecker species have this really great mustache. So this is a red mustache. Some species of this woodpecker have a black mustache. Anyways, let's put the woodpeckers away. Let's get back to the hack end. One has to love birds. I mean, birds are really fun. They're so unlike people. Okay, so we run our Linux foo. We will cut. We'll cut on the backslash. And we get the first field, the second field. Okay, so these are our users. And then we want to cut again. And this time we're going to cut on the space and get field 1. Athena.to. Athena SVC. I like Corvid, smart as can be. I mean, Yeah, corvids are the smarter. Well, they're one of the smartest birds. Okay, so we will. Next, we'll make sure that there's no white space in this file. So tr delete the spaces, and we output that to users.txt. Okay, so we've got 3 users. We could try to do some brute force attacks to try to figure out if we can get access to any of these users. So the first thing we need to do is we need to get a valid set of credentials. mprice is probably going to be, it's probably the intended method to get access to the mprice user first. So let's copy this. Let's go over to netexec, DNS admins. Let's see. We can do a little bit of, let's do a little bit of, what is it called? Brute forcing. So the user we're going to try to brute force is this one, mprice. And the password, we'll try every password in... I don't know if we're supposed to be doing brute forcing attacks. Realistically, brute forcing is not the way to get in. You usually want to do some... what is it called? Like password spraying is probably the better way to do it. Let's see what happened with our nmap. So 3389... 139, 135, 445. 445, 53. The problem here is that we don't really have any other places to enumerate. I guess we could... No. I think we could do brute force with Kerbrute, with Kerberos, instead of SMB. So there's... yeah, okay, let's try using Kerbrute instead. So let's see. Kerbrute... it's a pretty common tool used in... I'm not too sure if professionals use it, but CTF players use it a lot. So this is Kerbrute for Linux AMD 64. Let's copy this. And this is some fuzzing attack that we're going to be doing over here. We'll just download the file, then we'll make it executable, and then we'll rename the file. So we just want to call it Kerbrute. So move Kerbrute to Kerbrute. Done. What is the CTF? Task to complete? Capture the flag. Yeah, ATVOW. So CTF stands for capture the flag. So capture the flag is like an educational exercise. So capture the flag, educational exercise, is pretty common in cybersecurity. So we'll run Kerbrute in brute force mode. Hold on. The first thing I want to do is I want to look up what the name of is it called like user brute mode? Let me take a look at the repository. Easier to just move it to user bin, or you can run it from anywhere. I mean, it's okay. It's okay. It's okay in this directory. It's fine. I mean, if I were using Kerbrute very regularly, then maybe moving it into the user bin directory probably would be an easier thing to do. Why keep secrets on a computer? Keep it non-digital. Why keep secrets on a computer? I mean, you can try to not put anything sensitive on your computer. I don't know how far you'd get. Okay, so brute force a single user's password from a word list. Brute force read username password combos from standard in, and then test them. User enumeration. So we're going to be running it in brute user mode. And what is the name of this domain again? It's like dry martini something something. Depends on what it is. There's security concerns. Well, there's security concerns for everything. Dry martini bars. Okay. So the domain is drymartini.bars, and the DC the domain controller we're contacting is this one right here. Okay, and we need to specify a user in this case, right? Like user... What's the name of this guy? M-Price. Is that Hacknet video game any good? Hacknet. I mean, Hacknet is... It's okay as like a first introduction to cybersecurity-like concepts. I wouldn't say it's like super... It's not super accurate. It is kind of fun because there's a like a pseudo Linux terminal included in the game. The more you know about cybersecurity, the less fun it is. Let's just put it that way. Okay, so let's see. Let me see what the usage is for brute user. User enumeration, password spray, brute user. Okay, so brute user. The domain is this. The passwords is... Okay. So the username is the last thing you supply. So passwords and then username. So passwords is going to be user share word lists rocku.txt. Okay, ZB says true, just like the movies and TV shows are no longer tolerable. Yeah, I mean, the more you know about like realistic hacking techniques, the Hollywood stuff kind of makes you roll your eyes. Sigma says, the novel Timmy McGee's hacker skills to break through 9 layers of encryption on the firewall just to seem really dumb. I mean, yeah. So, I mean, it's kind of like... It's knowing like about a technical thing, and then looking at movie depictions of that technical thing. So it's hard. There's one exception that will... My go-to every time, doesn't matter the level. There is one exception. So is the exception... Hackers? The Hackers movie, or is the exception like The Matrix? Mr. Robot, of course. Yeah, I mean, Mr. Robot tried harder. It tried a lot harder to get its technical stuff accurate. It was more realistic, right? Okay, so this is just working in the background. But in the meantime, what else can we do? So we found 5985, and 5985 is associated with WinRM. So WinRM is like terminal login, no, it's like CLI access to the Active Directory machine, usually from like an administrative account. Okay, Mr. Robot was more realistic, like 90% realistic technically, compared to 0% realistic on Hackers. I'd say that they got more right in Jurassic Park than they did in Hackers. Okay, NetExec is over here. So what else could we be doing right now? I suppose we could be doing some SMB vulnerability scanning. Is there a Linux command similar to Windows Clip, where you can pipe output directly to the clipboard? So annoying to redirect output to a file, and then cat it to copy from there. They captured the culture in Hackers. That's true. They did kind of capture some of the 90s hacker culture in the movie. I mean, I wasn't part of it, of course. So I mean, I wasn't part of that culture back then. Some other people might have been. NCIS Hacking, the TV show. I mean, I've heard of NCIS, but I didn't know that they had like a specific hacking show. Okay, so let's do some... Well, after Nmap is done, we'll do some SMB vulnerability scanning. But like on a Windows 11 system, there shouldn't be anything super exposed. 2 people on 1 keyboard. I mean, that's how you type twice as fast, right? Is Frack the Zine any good? I mean, it's been going on for such a long time. It has to be okay, right? I haven't really taken a look at Frack myself, but a lot of people have a lot of good memories about it. It's still being published these days, but I'm not too sure how often it publishes. Maybe like once a month. Okay, so I guess we can leave this running in the background. We'll just call this terminal Kerberoot. Kerberoot user. Okay, Reddit would have so much InfoSec information. Phreaking isn't much of a thing anymore. I mean, phreaking isn't really much of a thing, but Frack was born in an age where phreaking was the primary method of doing hacking, because everybody was dealing with everybody was dealing with like phone networks instead of doing computer hacking. So mprice, Athena TO, Athena service. I mean, I guess we could do some ASREP roasting, which is a feature that you could do for. We can do it unauthenticated, I'm pretty sure. Let me look at my notes. Phreaking, what is that? First time I've heard of it. So phreaking is phone hacking. So like getting free phone service by sending like, what was it, tones? Specific tones into like a phone. Masterclass, DYKane has a masterclass on cyber warfare. Masterclass has a video on cyber warfare. 2600. I think that was like the name of a magazine as well. Okay, so we can do ASREP roasting from NetExec over here. So NetExec... ASREP roast. Did I spell that incorrectly? Captain Crunch whistles emit the same frequency for long distance. Hey, Jan Dizons, hello, nice to see you here. Oh, LDAP. So, ASREP roasting is not SMB, it's LDAP. What happened here? Something tells me that my... What's the difference between computer science and information technology? Computer science and information technology. I mean, what is for studies? Information technology is like the broader umbrella, and computer science is more specific. Let's see. Channel binding, no TLS cert. Signing enforced, channel binding, no TLS cert. So signing enforced is probably, this is probably because we don't have a valid user account. Okay, Hackers the movie didn't depict anything realistic about hackers or hacker culture. The only thing that was realistic is that there was a struggle to create valid handles for kids struggling to try and relate to people who are considered elite. I mean, a lot of people in cybersecurity have some pretty fond memories of hackers. I mean, I'm not too sure how realistic everything was in the movie Hackers, because I was not part of the hacking scene or cybersecurity scene back then. That culture depicted was more cyberpunk and Hollywood-esque. I mean, yeah, they're gonna make everything seem a little bit more flashy, yeah. Okay, so we weren't able to do the ASREP roasting attack. Now, what's another technique we could do without a valid set of credentials? So Kerber, I'm pretty sure that we need to have valid credentials to do Kerber roasting as well. Hackers was a fun, cool watch. I mean, it did like produce some pretty good memes. Okay, so we're still brute forcing with Kerberos over here. Nothing's coming out of that. What is DYK Masterclass? What is DYK Masterclass? I'm not really sure about that. Okay, Jan Dizon says, I had a modified Radio Shack device for retrieving Tor messages from your answering machine. Retrieving your messages from your answering machine, okay, if you want to a payphone and beeped it for free long distance. I wonder if that stuff still works these days. Probably not. Probably not. They would have patched that stuff out. Okay, netexec. What are some other like common? Try impact. Oh, you know what we should do? Maybe we should run some netexec modules. So there's a whole like there's a whole wiki for netexec. Yeah, using modules. Here we go. It stopped working while my girlfriend was in Berlin. 2001. Okay. The spirit of the Hacker Manifesto was covered by the script and the mentality, but nobody wore cyberpunk stuff like that. They were in like bright blue sports jackets or jeans with like dress shirts and pocket protectors. Hackers weren't that cool back then. Hackers were... are we saying that hackers are basically nerds? I mean, hackers are still basically nerds. Hackers are people who do like computer stuff. And hackers are exactly what you would imagine people who do computer stuff like might be. So we can run a module. What are some of these modules they've got? Running multiple modules. So let's see. IIS, LSASI, Win, scopy. Oh, okay. They want you to use several modules like this. Okay, The Simpsons has a portrayal of hacker nerds, okay? ChatGPT is a command for bug bounty hunters. I mean, you could use ChatGPT to help you do bug bounty hunting. Sure. Okay, Alpha says if one's production server got infected and one has found out the IPs of the attackers who used proxy chaining, does it make sense to track down the attacker for financial reasons, or will lawyer costs be too high for small companies? Okay, so if you manage to find the IP of the attacker who was using a proxy chain, I mean, is it easy to figure out what the original IP address is? You don't. You contact law enforcement or you hack back. I mean, I don't know if hacking back is the best solution in your scenario where you're a company. Hackback isn't authorized by any attorney. And GF, hello. Command? What are we talking about? We don't condone that in writing or videos. Yeah, I'd say that hacking back is not... It's not... I don't know if that's especially legal in any case. Okay, so we... What is this? So we got 53, 88, 135, 139, 389. We got LDAPs. We got some information about the machine. So it's DC01, dry Martini bars. Okay, and then we've got our WinRM. Is it safe to use a password manager? Is it safe to use a password manager? I mean, the question you should be asking yourself is it safe not to use a password manager? If you can manage all of your passwords yourself and you can ensure that all of the passwords are unique and secure, then maybe you don't need to use a password manager. But, I mean, most people, they need to keep track of several dozen accounts that all need to have unique passwords, so it's tough. I'd say that for most people, you should be using a password manager. When they get popped, they have the whole kingdom. I mean, if you're dealing with a company, if you're dealing with a password manager company that doesn't segment off the user information in a way that where it's very hard to have that actually compromised, then I don't know. I don't know if you should be dealing with that company. For the most part, I've never heard of a password manager company having any of their customer data leaked out, like, you know, password hashes for their master password or whatever. Okay, so let's just copy all this stuff to... Let's copy all this stuff to a file. Nmap 1.txt. Okay. Have you run Bloodhound? So before you run Bloodhound, you typically you need to have a domain user account before you can run Bloodhound. You can't run it beforehand. So we're not having any luck brute forcing this M price user. We could try some other. We could try brute forcing other users, but I don't know if brute forcing is the way in. Nmap, it says the domain controller. A lot of people are creatures of habit. There's a password run place, so it'll be used in another. I mean, the problem is we don't have any... Unless they're using password managers. If they're using passwords from password managers, that means that all their passwords are going to be different from each other. Pretzel Pete, what are we talking about? Have you run Bloodhound? On the Nmap it says domain controller. I mean, it says domain controller. That doesn't... I don't know what that has to do with running Bloodhound without domain user access. You need domain user access to be able to run Bloodhound. Let's take a look at some of the other modules. So SMB, you just run it with the -M, right? How do you get the list of modules? netexec lists modules command. Krishnarik says, Proton does recommend the remember me option. So could anybody let me know about this? So -L appended to your chosen protocol. So netexec protocol -L. Okay, let's do that. So for enumeration, we've got all these. So let's see. This one's for Eternal Blue. And then we've got coercion stuff. We got zero logon. I mean, zero logon would be pretty hilarious on this system. Okay, and netexec SMB shares. And we have taken a look at the shares on the system. It's just that we don't have access to a user who's got read or write access to those shares. This command shows the domain, and I think we already know the domain though. Just a second, I'm going to try, I'm going to start writing a little documentation on this. So this one's called MartiniAD. Okay, you already ran enum for Linux NG. I mean, I'm not sure if that's like a standard tool to run. Did you check inside the SMB? We've been checking a lot of SMB stuff. Enum for Linux NG. I'll give it a shot. I don't know if I've gotten it installed or not. Enum for Linux NG. NG. Okay, not installed. We can install it. Give it a shot. What does NG stand for? Next generation. Could email my notes to you. Pretzel Pete, have you finished this module? Have you done this module before? Or are you talking about notes for Windows Active Directory testing in general? enum for Linux ng-a on the IP address. Where's that thing? dry.martina.pars. Oh, and I mean, you don't need to send me your notes because I'm trying to do this without help. Okay. I mean, I haven't really used enum for Linux ng. I have seen it, but it might be a good thing to run because we're getting some information here. Would you drink a dry martini? Add DC01 to your host also. Oh yeah, that's probably a good idea. Yeah. Let me do that right now. DC01. Okay, helpful map. Okay, so SMB, there's LDAP, there's LDAPs. Domain information. So let's see. SMB 1.0, 2. This stuff. So it doesn't do SMB 1.0. And then we've got fully qualified domain name DC01. So server allows authentication by a username, something, and password. So random thingamabob and password. Okay, we got some information about this version of Windows. Huh, it says Windows 10 here, but from netexec it told us it was Windows 11. I'm more inclined to trust like netexec over this enum for Linux. Okay, found 6 shares. We got admin, C, IP, C, net logon, and then we got notes. So what we want to do, we probably want to access this notes file share at some point. And then, yeah. Spoiler alert. Spoiler alert. Windows 11 is still Windows OS version 10. Really? I didn't know. I didn't know that that Windows 11 is actually Windows 10. That's funny. Okay, so Kerberoot still hasn't found anything. RPC wouldn't lie, would it not? Okay, 26200 is the most recent build for Windows 11. What is it? Up here? This one. OS build 2620. So this is 2610. And it still says, I guess all Windows 10, all Windows 11 is going to show up as Windows 10. Still dated, but not completely out of date. Alright, so I can't remember where that actual... But there was like a flowchart, right? It was like an Active Directory testing flowchart. Or like a checklist, a flowchart, something. Wikipedia has a bunch of Windows builds. Okay. I remember our good friend Defus. Defus had like a link for an Active Directory like list. Yeah, I think that might have been it. Okay, let me take a look. Mind map is what it's called. Okay. All right, let's take a look. Okay, no credentials, scan network, find domain controller IP, zone transfer, anonymous and guest access on SMB shares, enumerate LDAP, enumerate users, brute force users, poisoning, coercion, PXE, time roasting, quick compromise, zero logon. So we need to go and check for a zero logon with the module. So zero logon is going to be, is that SMB? Time roasting is a good one. I don't think I've ever heard of that before. But I can check it out, because why not? We don't have anything. We have anything more pressing to get to. Okay, so what's time roasting? Time roast.py, time roast hash. I've never heard of this. Time roast .py. Well, that's not a website. Script. Have a fun time with this lab. Well, I mean, okay, so time roasting. It's a script. It's an offensive security tool used in Active Directory assessments to exploit the legacy MS and SNTP authentication extension that allows unauthenticated attackers to request and capture the password hashes of domain controllers, of domain computers and trust accounts, which can then be cracked offline. Okay, well, we've got the GitHub repository over here. All right. Let's go ahead and clone the repository. We can even give it its own tab. Time roasting. So we'll git clone that. Okay, so we got time roast. We also have a PowerShell script. So Python time roast usage. The following arguments are required: DC. So time roast on, well, we'll just give it this. It might not, nothing, it could be that nothing comes back. Did we get something? Sorry, we see something here. Okay, so both the Python and PowerShell scripts should run standalone with no dependencies. Okay, time roasting takes advantage of Windows NTP authentication mechanism, allowing authenticated users to effectively request a password hash of any computer or trust account by saying NTP request. Okay, the output of time roast.py can be fed directly fed to hashcat. Use hash type 31300 MSSNTP and use the username flag. Use the username flag. dash dash. Okay. You have to crack that now. Yeah, I guess so. So extra scripts Kirby to hashcat.py converts a Kerberos ticket that is encoded as a base64 cred into hashcat format. Time roast. Okay, so I mean this is our hash, right? Time roast.hash. We'll nano this. And thank you very much, xhister, for following on Twitch. Thank you. Alright, so the output of this can be directly fed to hashcat. Use hash type 31300. Where's our hashcat command? Hashcat username time roast dot hash, and the mode should be 31300. You've enabled force to bypass dangerous warnings and errors. Cannot open shared object file. No such file or directory. No such... Do I need to download a new module? Hash type 31300. Okay, there's no bin in Linux, so every deleted file completely gone from the system isn't there forensics? I mean, you're talking about the recycle bin, right? When there's no recycle bin in Linux. I've heard that you can recreate something like a recycle bin in Linux if you use some third-party software. But you can retrieve deleted files from Linux systems. You just need to do some disk image forensics. Okay, let's do a little bit of research over here. So hashcat mode this. Hashcat mode 31300 is used for offline brute force attacks against SNTP, Microsoft Simple Network Time Protocol, cryptographic hashes. It targets the authenticated NTP blah blah blah, okay? So this is part of the time roasting attack. So let's see. Hashcat 31300 username -- username. Okay. So I mean, I think that's exactly what we're doing here. So let's see. Maybe we're supposed to put -- username over here. Yeah, that doesn't have... I guess we need to update our hashcat. Extracts hash is in file where each line is username hash. Oh, okay. I think... So sudo apt update and sudo apt upgrade hashcat. So we just want to upgrade hashcat so that it has this particular module. Because I'm pretty sure... I mean, the other way we could do this is we could see if John the Ripper has some method of getting this done. Cat, your hash, it looks like it might have been pasted wrong. Space needed. That's a lot of megabytes. That's a lot of megabytes for just... That's a lot of megabytes for just hashcat. Sorry, what are we supposed to be doing? Okay. Suggested packages. Install dependencies. Hold on. I do not agree. No, do not continue. I mean, this looks like the time roast hash. Let me check it again. Let me do the attack again. Just to make sure it's the right hash. It's a different hash. Huh. That's funny. Is it going to be a different hash every time we run this? You have to use a modern version of hashcat to crack that. Okay, so hold on. We just want to upgrade hashcat. It seems like it was trying to upgrade more than one package at a time. So is this the correct command? So sudo apt update and sudo apt upgrade hashcat. Upgrade equals everything. Oh, how do we specify one package? Linux update one package only. Apt install cachecad. Apt install cachecad. Okay, so space needed 43 megabytes. That's much more reasonable. Okay, I agree to this. Okay, let's run the thing then. So hashcat. Okay, looks like it's working. So we'll just leave this running in the background. I'm pretty sure that our Kerberos brute forcing are using -- username. I think I am. Yeah, so -- username is here. You running bare metal for GPU? Are we running bare metal? I think I'm using, I'm using my, oh, it looks like we're using CPU. We're not running GPU. I've never really exhausted. Okay, so we didn't crack it. Do you have like a course for cybersecurity? Yeah, kind of. I've got a bunch of courses for getting into, for learning beginner skills for cybersecurity, yeah. Check out this website if you want to. The CPU is in the VM, yeah. So we're not using our GPU to crack these things. So let's see. We weren't able to get a proper hash for this. All right. attack failed. Target is probably patched. I mean, the other thing we could look for is we could look for good old Eternal Blue. It's not likely to be there, but we can give it a try anyways. Eternal Blue won't work here. Yeah, I mean, it doesn't. I wasn't expecting it to. Okay, so let's look at that. What was it, a mind map? So Chorus, time roasting didn't work. I mean, the other thing is that we might need to use like another word list. What is the thinking process when hacking? The thinking process when hacking. Check everything and everything, but starting with things that are more likely to get you results. The thinking process with hacking is knowing the system. Also experience. Windows servers 2008, 2012, and 2016 were Eternal Blue candidates. So Eternal Blue absolutely won't work on. Well, I mean, I'm sure you could do something really wacky to modern versions of Windows to make them vulnerable to Eternal Blue, but you'd have to go out of your way to mess with the computer, to mess with the operating system. 2019 plus, we're already patched out of the box. +1 to poke. Hello, Santa Vice, nice to see you. So enumerate users, brute force them. Poisoning, coerce. Quick compromise, Eternal Blue, Tomcat, Java, Log4 shell. Okay. I don't know if you want to call me sensei or not. That's kind of weird. Well, I mean, not weird, but you know, I don't consider myself any sort of expert. So ASREP roasting. So we tried to do some ASREP roasting, didn't work. I guess we could. Can we do Kerber roasting? I'm pretty sure we can't do Kerber roasting unless we have like we've got a domain. I am teaching, that's true. Okay, so Max asks, how can we actually exploit? Like, I get stuck in reconnaissance, I can't find how to exploit. So I mean, the thing is that we need to. It's all about experience. It's all about experience. If you can enumerate all you want, but unless you know what you're looking for, the enumeration doesn't really lead anywhere. You have to know what you're looking for. Password spray, so valid user, no password. So valid user, no password, we could do password spray, okay? We could do ASREP roast. Valid user, we found the user, but we don't have the password. I guess we need to leave the password blank in this case. Let's give it a try. Pretty sure. Okay, so the account we've got, well, that we know about, there's a few different usernames. There's mprice and there's the tina.to and all this other stuff. Oh, this has to be LDAP. Just a second. Okay, no TLS cert. So this means that we've got no ASREP roasting. Let's run the brute force attack on another user. Okay, time roasting. So my question about time roasting is that do you always get a hash when you do time roasting, or do you only... Okay. Let's do a bit of research. What is time roasting Active Directory? Okay, Active Directory attack technique that exploits the network time protocol, blah blah blah. Okay. Attacker sends a specific unauthenticated network time request. Okay. Calculating a cryptographic MAC, message authentication protocol. Sure. Attacker captures this and uses offline brute force tools like Hashcat to crack the password associated with the computer's hash. So no authentication needed. Computer accounts are vulnerable. So if attackers successfully crack a computer's account password, they can leverage it for lateral movement, blah blah blah. Okay, great. So the thing that I'm kind of confused about is that we ran the same attack a couple of times. So we have our hash here. And we got a different hash when we ran it another time. So is that supposed to be regular or not? Yeah, Mr. Meme Lords, hello. Yeah, we're running Kali in a VM, yeah. That's what we're doing. We got a different hash here, and I'm pretty sure that if we run it again, we'll get like yet another hash. So this one ends in F4, this one ends in IF, this one ends in 67. Sorry, not 67, E7. Got too much zoomer on the brain. Okay, so let's ask a question to our good friend, the AI. Oh, you're new here, Mr. Memes Lord. No worries, no worries. Okay, I am researching the time roasting AD attack. Is it normal to get a different hash each time we do the attack? It's normal. Oh, I mean, I guess the hash also takes into account the time when the attack was made. Okay, so what are we talking about? Is it about an IP address? No, we're not really talking specifically about IP addresses. Okay, with time roasting, it's completely normal to see different hash each time you roast the same computer account. The underlying password stays the same, but the captured value is salted with NTP data, so the resulting checksum changes between runs. Okay, so it's a point in time. Okay, that makes sense. Many non-tech head of nonsense guys I've talked to just say that update it as soon as one is available. Will updating fix the security issue? Wait, when we were talking about updating fixing security issues? Okay, so I guess in this case, we either need to come up with a new word list, or the time roasting attack isn't going to work. Okay, we might give this another 30 minutes, and if we haven't made any progress in 30 minutes, we'll take a look at some cheeky notes. Okay, Max asks, how can we use AI in this process because AI is restricted output most of the time. AI restricts the output most of the time. I mean, are we talking about, what are we talking about? Are we talking about AI not being allowed to talk about hacking stuff? You can get specific LLM models that are allowed to talk about hacking. You usually need to pay for the service, or you need to host the service yourself in order to get that. But you know, there's usually some sort of workaround if you want to talk about cybersecurity and hacking topics with the LLMs. Okay, password spray, as rep roast, man in the middle. Man in the middle. I mean, I don't know if we're supposed to be running responder.py right now. I guess we could. There's a bunch of stuff we could be doing. Okay, responder. .py. So we can just run it over here. Ooh, responder. Do we need to give like an interface? I ton 0 must be run as root. Okay, let's run that as sudo then. Okay, Sick the Mind says unpaid AI definitely restricts attacking and exploitation topics. We could, but we don't want to. We're trying to learn. I mean, I'm okay. I'm perfectly okay, you know, asking the AI to help me with certain topics, especially stuff that I don't know too much about. It's actually very difficult to just say, "Hey AI, hack this thing for me." It's not exactly how it works. Okay, Max72 says new to hacking. Yeah, what kind of issues were you having? You said something about doing a lot of enumeration, but not being able to identify what to look for the exploit. Domain name something.local. Alright, so we've got it running in the background. Let's give it a fancy color. How about some yellow? So Kerbroot hasn't been able to find anything for either of the two user accounts that we've been brute forcing here. I'm not understanding which sources to use to learn the theories and methods. So the thing is that you should probably identify what kind of role you want to do in cybersecurity first. That should be the first step. The first step is to think to yourself, what do I want? Where do I want? Which direction do I want to take in learning cybersecurity? What's your end goal? Do you want to be a network security tester or web app security tester or like a cloud security tester? Do you want to do digital forensics? Do you want to do defensive cybersecurity, incident response? Check out the website over here. Kerberos relay attacks and TLM relay. So this is responder PI stuff. Hash cracking. An interesting thing about this is that they're actually doing the like hashcat hash cracking attack, but they're doing it in brute force mode. Maybe I should try this. Okay, so this is time roast. Then again, this could take a really long time. This could take a really long time, but you know, no hash is loaded. Token length exception. This error happens if the wrong type of hash type is specified. They're malformed. Oh, okay, we need to force the username thing. Okay. We'll just leave this running in the background. You need to use A0. Oh, we need to supply like a... Wait, which one is A3 then? Okay, we'll just leave this running in the background. 0 is list. No worries, no worries. So what about these coercion attacks? I'm not too sure if coercion is going to work on these modern systems. We got poisoning. Zone transfers. Oh man. I mean, I guess we could try. We could try like a zone transfer. The DC is the DNS. Okay, domain name at name server. So the name server is the IP address. And the domain name is, what was it, dry.something something? Dry.martini.bar. Okay, they don't let us do the transfer. At must use an IP. Yeah. Okay, so the transfer didn't work. Wait, did we find something? Okay, session exhausted. Okay, we weren't able to find anything. So what else can we do on unauthenticated? You want to ask something, Mr. Memelars? No worries. Ask away. Coerce, time roasting, 0 logon. As rep roasting, password spray. What's on this end? Valid credentials. We don't have valid credentials. There's a lot of stuff here. Known vulnerabilities, low access. Known vulnerabilities authenticated. Oh, these are authenticated ones. Did you do LDAP search? No. Let's give it a shot. So enumerate LDAP search over here. Is this mind map comprehensive? I'd say that it's a lot better than what I've been doing, kind of like winging it. Could not parse our LDAP URI. Do we need to feed this the domain? Hold on. Oh, bars with an S. Okay. Never mind. Still doesn't like this, huh? Okay, I like your terminal look. How can I want to try it? I mean, the terminal look here is from the terminal Qt. Qt or QTerminal? This is the standard terminal on Linux. Sorry, not on Linux, on Kali Linux. So if you get your own Kali Linux virtual machine, it should have this by default. So dry.MartiniAD bars. Hold on, let's try the LDAP search through here. Could not parse LDAP URIs. What's wrong with my syntax? All right, let's do a search. It might want LDAP --IP. Uh-oh. Yeah, that's what it wanted. Thanks, Sick in the Mind. I use Kali. Everything is available on it. I mean, a lot of common security tools are on Kali Linux. The reason why a lot of people use it is because they don't want to have to... They don't want to have to install everything. That they don't want to install all the security tools. They want something that already has all this, most of the security tools that they're looking for already installed on it. And there's nothing magical about Kali Linux. It's just a version of Linux that has a bunch of security tools. So the DC dry martini bars, okay. Using Kali is a good excuse to not install Linux. You're looking for Black Arch. Of course we are. Eridelson, hello, nice to see you here. Thank you very much for subscribing on YouTube. Much appreciated. So here's the thing. So we were doing some... So password length is 0 to 256 bytes. I wonder how we could adjust this payload to make it a little bit more inclusive. You get a list of users with NXC. Unauthenticated LDAP bind. Is putting photos on dating on dating apps a big insecurity? I mean, this is how you play the game. If you don't put photos on dating apps, people aren't going to pay attention to you. I mean, I suppose you could get away with not posting like pictures of your face on your dating app. It's just that you're not going to get very many responses. Okay, so let's say we wanted to do netexec LDAP user enumeration. Your vector based on the fact that there's unauthorized LDAP bind is probably going to find a password or some kind of information from a user in the LDAP attribute, or you can get a dump of users to curb root. Okay, so netexec for I mean, I think I've done one or two exercises where LDAP information has led to like passwords and stuff. Okay, LDAP authentication. Authentication. Testing if an account exists without the Kerberos protocol. Testing credentials. So there's no... Oh. Wait, that means we could probably... Okay, so we've got the usernames. So if we have usernames, we can check their LDAP description. By the way, I've only ever done one cloud box on HackSmarter. I've been locked away in my pursuit of OSCEP, OSWE, to explore the platform in depth. Okay, and how are you doing with that with the course? Are you having a good time? Okay, so I think specifically we want to use netexec to get LDAP user description. Okay, to retrieve LDAP user descriptions with netexec, you can use either the native query command to fetch specific Active Directory attributes or utilize the dedicated module. Okay, so what is this? Let's copy the module method. So if you're specifically hunting for keywords or sensitive data accidentally stored in user descriptions, use the built-in get description users module. Oh, maybe I want to use this one instead. But I mean, we need to have username and password. Well, we'll try this one first. And sorry, unauthenticated LDAP. Right, okay. We'll try this, we'll give this a shot. Okay, so password nothing, username nothing. And the target IP is dry.martinia.bars. Okay. In order to perform this operation, a successful bind must be completed on the connection. How about guest? Okay, meme lords, what were we talking about? What was the name of the default theme on this terminal? Default theme? Preferences. This one is green on black. So the color scheme is green on black. So this is the one I'm using. Okay, so I guess get description users isn't working here. The other one is this one right here. LDAP search can do it too. That's just a tool issue. I mean, the thing is that I'm trying to use as much netexec as possible because NetExec is the all-in-one tool that does all your Windows hacking stuff. But I guess they don't want to give us this kind of information. Okay, Adval says, is Google safe for use for data privacy, or should I start using Start Page? I'm not completely sure. I mean, privacy is not my specialty. I know a lot of people who are super into privacy as far as cybersecurity is concerned. Okay, so we're gonna get our first hint. So the first hint, we're just going to get ourselves unstuck, and then we'll take it from there. So we got our official walkthrough over here. We're gonna figure out what the actual thing is. So recon, they recon using Ruscan. And then they find all the ports. And then we follow the orange cyber defense mind map. Okay, that's good. So we were able to successfully authenticate as guests, and we immediately find a share called Notes that we are authorized to read and write. Wait, I didn't see that we could read and write from it. Oh, I misspelled the word guest. I misspelled the guest account. That's really dumb. It's really dumb of me. I spelled guest with a capital G. Okay, let's go back. They used SMB. Yeah. Okay, let's go into it. Guest. So I tried using guest with a capital G when I did my first pass. Casing doesn't matter. Does it not matter? And then I looked for shares. So I ran this exact command right here. Just didn't like it for LDAP. I think when I did this, yeah, I did like this is the issue. So I did it with the unauthenticated. Yeah, read write on notes. So if we have read write on notes, then we can just I feel really dumb. But anyways, we can correct our mistake, and we can use some SMB client. SMB client on notes. And the user is going to be guest. So this is dry.martini.bars. No password. Okay, so we got notes.txt. This is probably going to give us some credentials or something. Get that thing. And then get out of here. We got some credentials. Okay, so we got M. Price, whose credentials are Martini. Yeah, okay, we're off to the races now. Prime Retro Gaming Music. Yeah, thanks. Okay, so now we've got I'm guessing this is going to be domain creds. If we've got domain creds, there's so much more that we can do. How long to learn a programming language? Say Python or C#? Python? I'm gonna say something like half a year to get good at, well, not to get good, but to get the basics down and to start writing code. Python is probably going to be faster than a lot of other programming languages. Just do a course. So take a look at the education resources over here, and then take a look at the resources for Python. So go to this page and then programming and then Python. Adva says, I ate like 6 pieces of pan-fried fish and fruit. Yeah. Yeah, hope you had a good one. Okay, what was that username? mprice. Okay. So we can do, this opens up so much for us. So SMB, just need to make sure that this is correct. Yeah, I think this is good. We'll check to see if they've got WinRM access. Not likely, but just gotta check. Okay, so they do not have WinRM access, and we'll check. We'll see if we can get a list of users, although we're pretty sure we already know all the users on the system. Okay, we got an ad, we got ads running on Twitch. So when ads run on Twitch, we put on the birds. Here's my favorite bird video. We'll be back in about 60 seconds, but enjoy the birds and enjoy the music. So Apple asks, can I enroll in the Cisco programming course number 2 without doing number 1? I'd say no, because if you're talking about the Python ones in particular, they kind of build off of each other. So definitely do number 1 before doing number 2. Okay, Athena SVC, Athena.to, we got all these. Okay, so I guess they've got an exam. They've got an exam? You're talking about the Cisco programming course? You can't pass the exam. Did you do the first programming course? But you couldn't pass the exam. I mean, why? The question is, why can't you pass the exam, though? If you took in the information that they taught you in the course, you should be able to pass the exam, right? Okay. But I'd say go back and revisit it. After a bit of study, you should be able to pass that exam. Okay, so now that we've got credentials, we can do all of our attacks again. So we can do ASREP roasting. We could try Kerber roasting. Oh, this is supposed to be LDAP. LDAP. Long hard course, lots of reading. Sorry. As rep roast. Oh, no ing. Expected 1 argument. Oh, this. Okay, I can enroll in many Cisco courses. Is there a limit? I'm pretty sure there's no. I don't think there's a limit on there. No entries frowned. So no as rep roasting. So we can also do curb roasting because we have a domain account, and I just need to remind myself what the command is for curb roasting. Okay, so we run the same command, but it's curb roasting. Where is that thing? And we found an account. We found a curb roasting account. Okay, so we just need to crack this this hash then. Output.txt. So this is our user account. So our service account that has we just need to crack it. So we run, I think it's like hashcat. Let's run in another tab. We'll call this curb roasting. So we're running a hashcat command. Let me get out of this directory first. Okay, so we're trying to crack the password for the service account. And we'll see if we're able to get any results. But there's a bunch of other tests we can do now that we've got. Oh, we got it. 1 dirty martini. Alright, that's good. So now that we've got access to this service account, so this is called like Athena service, let's add this to our list of credentials. So creds.txt. Athena SVC. And the other account that we've got access to is mprice. And mprice's password is martini. Okay. So we're just keeping track of all the stuff that we've collected so far. Now what we need to do is we need to figure out what this user has access to. So let's go ahead and do that. I'm pretty sure this user's not going to have access to... We probably need to do some Bloodhound stuff. So now that we've got access to domain accounts, we should be able to do some Bloodhound enumeration. It's been a really long time since I've run any Bloodhound. Okay, so the first thing we want to do is we want to take in the Bloodhound information. So it's going to be a command that looks kind of like this. Can't they put a limit on how many passwords you can input? Yeah, they can. I mean, it really depends on which protocol you're attacking as well, because the number of times you can try a password on a particular account, it might change from the LDAP protocol and the SMB protocol and the WinRM protocol and the Kerberos protocol. If we're talking about cracking, then no. Cracking is an offline attack, and they can't impose limits on how many times you try to crack a password. Cracking is offline, and brute forcing is online. So you just need to keep that in mind. Okay, so let's provide the credentials, and then get the Bloodhound information. And we're doing DC01. This domain is called dry.martini.bars. And then we need to provide the DNS server, which is the IP address. Okay, this should get us our Bloodhound information. Oh, what happened? An exception when calling protoflow dry.martini.bars. Connection reset by peer. Am I still connected? I should be still connected. Let me try ping the thing. So this is a VM in Linux? Yeah, well, this is a VM on Windows. So my host machine is Windows. The VM is running Linux. No, I still have access. So why did it give us an error here? DC01.dry.martini.bars. Maybe I shouldn't use that. Although dang. Can you do the opposite and run Windows from a VM in Linux OS? Yeah, nobody's gonna prevent you from doing that. Let me take a look at my etc. host file. So DC01 dry.martini.bars. This should work. Maybe I shouldn't be using the service account. I'll try another account instead, the Martin account. So it's like M price. I'm not too sure what's going on here. Okay. Let's feed this into the our good friend the LLM. Maybe it can give us an answer. Okay, is there something wrong with my netexec command? Let's copy the entire error dump over here. Although it's probably not gonna like, it might not like this much information. We'll find out. Okay, so the command structure is correct, but the error is caused by LDAP signing being enforced on the domain controller. Here's what's happening. So LDAP signing, sure. Signing enforced. Credentials are valid, but Bloodhound collection fails during the second LDAP connection attempt. Automatically tries LDAPs when signing. LDAP signing is enforced, but if the DC doesn't have valid TLS certificate configured, the LDAPs. Advow says, "Do you play computer games?" Yeah, we were playing games earlier. I mean, I don't have as much time to play games, of course, but you know, it's fun to play games, and playing games is all about interacting with systems. That's what hackers love to do. Okay, but if the DC doesn't have a valid TLS certificate configured, the LDAP's connection gets reset. Okay, option 1, use no brute force, and specify port explicitly often helps. So use no brute force, use a specific port. Okay, we'll try the specific port first. It still doesn't like this. Okay. Option 2, use Sharphound instead. More resilient to LDAP signing. Download Sharphound and run it. I mean, I don't know if I can run Sharphound because... Option 3, use Bloodhound.py with LDAPs disabled. Similar to Certi.py workaround. The issue is that ImPacket doesn't handle LDAP signing well. You may need to update netexec to the latest version, or use LDAP search to verify LDAPs works first. Okay, disable LDAP signing on the DC if you control the environment. Well, I mean, I don't. Okay, no brute force. I mean, we can try adding this to the end. Yeah, it doesn't like that. Okay, so if we can't get our Bloodhound information, I mean, there's a few other things we could do. One tip, shut down and restart in Linux after you run into your computer. There's different things. Shut down, then press start. Pardon me? One tip, shut down and restart in Linux after you run into a computer problem. For different things, shut down. 6364, hello, nice to see you here. What is up? Okay, so this thing's still running. We did the Kerberosing attack, and the Kerberosing attack worked. So maybe what we need to do is we need to take a look at the mind map to see what happens after we successfully Kerberos. move to the second part here. So crack the hash. We've done this already. Man in the middle. Valid. Valid credentials. Classic enumeration. Curb roasting. So we did the curb roasting. Okay, Sam Flores, hello, nice to see you here. How did you make the terminal title color-coded when you open it? I did that manually. So I went into each one of these tabs manually, and then I chose change title color. I wish I could get it to do it automatically. I haven't managed to figure it out. Okay, Advow says, I had a problem when starting up Linux. I chose to restart and ran into problems. The solution was to completely shut down the computer and then start it up again. Yeah, I mean, when you run into problems, sometimes to make sure that the problems aren't happening still, you need to restart your computer, shut it down, start it back up again. Okay, so the problem here is that we can't get our Bloodhound stuff. Use bloodhound.py with LDAPs disabled. Verify that LDAPs works first. The error is caused by LDAP signing being enforced on the domain controller. LDAP signing. I thought we came to the conclusion that LDAPs didn't have signing. Okay, maybe we can... So netexec, we're trying to get run Bloodhound. Collection LDAPs signing. Enforced. Okay, LDAP Bloodhound collection does not correctly save what? When LDAP signing and channel binding is enforced on the domain controller, default LDAP connections will be rejected. You must target the LDAPs port and provide valid credentials. So we need to specify 636. If no QTerminal instance, start with one chosen profile in a new tab, then use QTerminal tab profile. I mean, if we could write up like a script or something that automatically creates tabs and colors them, that'd be pretty useful. Okay, so we need to target the other port. Failed. LDAPs may not be configured. LDAPs may not be configured. Really now? Yeah. I mean, the other thing we could do is we could just look at this user's permissions manually. Using Bloodhound would be a lot easier, of course. Okay. You must target LDAP's port 363 and provide valid credentials. Verify if LDAP signing and channel binding are enforced on the domain controller. Okay. So we run LDAP checker. Removed. Now natively supported in the host banner. Okay, so signing enforced, channel binding, no TLS cert. Signing enforced, channel binding, no TLS cert. So if there's no TLS cert, that why is it using LDAPs and not LDAP? It's a good question. So this is... So this is LDAP over here, 389. The other port is LDAPs over here. Okay, so let me think about how much more time we're going to be spending on this exercise. Maybe 60 minutes. Need LDAP, not LDAPs. Okay, signing enforced, no TLS cert. So channel binding, no TLS cert. Okay, there is no TLS cert for LDAP. Port 389. Okay, your command is correct, but netexec cannot collect Bloodhound data because LDAP signing is enforced. No TLS certificate exists on the DC. Impacket doesn't support LDAP signing and automatically falls back to LDAPs when signing is enforced, but LDAPs fails without a certificate. Okay, so use an alternative tool that supports LDAP signing. So powerview.py, BloodyAD also works. BloodyAD. Okay, let me see if I can get that tool. FMS, do you agree the more gadgets you buy and play with, the better you get with technology? I mean, the more gadgets you buy, and it really depends on whether or not you're really if you're really spending a lot of time with each one of those gadgets, or if you're just buying the gadgets and not doing anything with them. You get what you give, is what I'd say. So BloodyAD, is that what it's called? BloodyAD. Is it like a GitHub thing? BloodyAD, okay. Active Directory privilege escalation thing, sure. Swiss Army knife. Okay, the tool can perform specific LDAP calls. Well, I mean, if it works, it works. Well, let's see if we can... How do we install it then? Auto Bloody. Sample usage, sure. So how do we install this thing? BloodyAD. Maybe I can install it from the from the terminal. Yeah, okay, so we can install it from the terminal. Okay, Sathi asks, can you do an Arch Linux setup in a VM in maybe your next live? I don't know if that's a very effective use of my time. I mean, Arch installing Arch Linux, I don't know, I might do it as part of like a subscriber goal or something like that. Okay. So you use domain, username, password. And we might as well put this in its own... I've got too many tabs going here already. Okay, let's rename this one. This will be my bloody AD. Okay. So there's a wiki for this as well. Great. I think they were talking about the specific commands here as well. So bloody AD also works. So bloody AD something something. All right. Let's try this command to see if it works. There's an ad running on Twitch right now. So we're just going to take a little break and have a little water. And in the meantime, you can watch the birds. Where are my birds? Oh, this one's a really dramatic one. All right. All right, we'll be back in about 30 seconds. Okay, I'm pretty sure that the relationship that these two birds have is that one is the mother, one is the mother bird, and the other one is like the baby bird. Anyways, let's put the birds away and then we'll get back to the hacking. Alright, so what do they want? -H for host. -H. Well, we did... The following arguments are required. -H or --host. How about we do this then? Many psychology classes. Yeah, probably. Where are we? Bloody AD also works. There's like a wiki for Bloody AD. You can check the installation guide or the user guide. Enumeration techniques. So username, password, Kerberos, certificate. Thank you for following Eset Shrapa. Hello, nice to see you. Thank you very much for the follow. Maybe order H before DNS? Yeah, maybe. It might be a position thing. It's still saying that we need the argument, though. It's weird. So d-domain. Oh, maybe we're missing domain? So the domain is dry.martini.bars. Username, password, DNS, DCIP. So, I mean, we'll include everything we can. Hosts. DC. I like how the AI recommends commands and the commands get a syntax error. It happens all the time. Okay, let's do TLDR. TLDR bloody AD. Nope. Okay. So D domain, domain used for NTLM authentication. U username, P password. Let's see, H host, hostname or IP of the DC. So the host, so the DC is DC01 dry MartiniAD.bars. This should be correct. Dry.martiniAD.bars, DC01 dry.martiniAD.bars. Okay. DNS is this IP address. Username, password. The IP of the DNS to resolve AD names. Okay, so we've got DNS. Command arguments. Add commands. So maybe it's looking for host first. It's looking for the host. I think it's looking for the host name first. So we'll just paste it in over here. Why is it not working? Let's copy this command exactly and see if we can. Oh no. I copied too much. So host name, dry martini.bars. I just need to make sure that nothing is misspelled here. Okay, and then we get the host name, DC01. We get our username, which is this thing, and our password. Bloody AD command not found. What do you mean, Bloody AD command not found? What? Have you been to a DEF CON event before? Oh, that's true, that's true. Caps. No, I haven't been to... I haven't been to a DEF CON event before. The timing has never been right. It costs a lot of money to go to DEF CON, and the tickets are like $500 American each. I'm Canadian, which means that $500 American is like $700 or $800 Canadian. It's a lot of money. All the IP examples of IP for H, really? All right, we'll put on the IP then. It still doesn't like it. Maybe the domain is just at bars. Thank you very much for subscribing. Did you know? Hello, nice to see you here. Thank you very much for the subscription on YouTube. Still talking about these arguments, huh? Sherpa, no problem. It's fine, and I'm just trying to debug this thing. All the suggestions are appreciated. Thank you. And I'm just not too sure what I'm doing wrong here. Maybe so. Okay, if if you're having a hard time, you could try passing it over to the AI, and then maybe, you know, maybe it has some insight that you don't. Maybe it's going to spot that I misspelled something. Okay, there's something wrong with my bloody AD command. Okay, the issue is that -H is not a valid flag for bloody AD. You should use host instead. Okay, sure. Let's put --host instead then. Nope, it doesn't like that. Thanks, AI. You're helping a lot. So it could be that my bloody AD program just might not be installed correctly. I'm not sure. April says, join a real country? A real country. What are real countries? Let us know. Okay, I see the issue now. You're using an older version of bloody AD that uses -H, and the example commands are for a newer version. Do we need to update this? Hold on. Let's try sudo apt update and install sudo apt install bloody AD. Okay. Cyber Sky, hello, nice to see you here. What is up? Maybe we need to clone the GitHub repository instead. They've got a guide for installing this thing, too. So there's an installation page. So dependencies, Python 3, MS LDAP, and DNS Python. So a Python package is available. So pip install bloodyAD, or you can clone the repo. Okay, so cloning the repo is probably the easier thing for me to do, but then we need to pip install. Okay, so if I want to install bloodyAD, I probably want to do it in a virtual environment, a virtual Python environment. Let me go ahead and set that up. Pretty sure I might, yeah, I've got a virtual environment set up in here. Okay, so we'll call this our Python bloodyAD. And we're in our Python virtual environment. We do pip install bloodyAD. Okay, and then let's try running it now. Thank you very much, CG, for subscribing on YouTube. Thank you very much. Okay, now let's try running these commands. Are you still giving me the same problem? It feels like it feels like I'm being trolled right now. Okay, let's get the help. So the help is here. Options, domain, username, password, format. Let's just provide everything. -d domain, so -d, I think it's like bars. Well, let's see, -d domain, -u username. Nullsec says, migrated to Twitch, your restream is stuttering on YouTube. Really? Am I having problems on YouTube? It says this stream is healthy on YouTube. People on YouTube, are you having issues with the video on YouTube? Let us know. Yeah, I'm not sure. I'm not sure where the problem might be. So domain bars, and then username, password. Let's just only provide the host name. It keeps on giving me this error message. No matter what I do. Oh, man. Have we tried logging in using the account creds? I mean, we can't log in via regular SMB. We need to log in via a user that has access with WinRM. So where did we... So let's see. We got the Athena user over here. And let's see if they've got WinRM access. They probably don't. They do! What the heck? Why does this service account have WinRM access? This doesn't make any... Okay, sure. You know what? I believe. I'll press the I believe button. All right. So since we've got access via this user, we'll run. Okay. Let me copy this over. We'll go over to remote access, and we'll run evil WinRM. Hack the planet. Evil WinRM. Okay, and then we'll try to log into DC01 dot. So I think it's like host, username and password like this. Okay. Evil WinRM IP. Okay, so they want an IP. Maybe the host name will work here. Okay, and are we in? We're in. All right, well, I guess we can call in Scary Hacker Voice Man to talk about how we broke into the system. Just a second, everybody.
Hey everybody, it's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into the system, and we just broke into this one. Well, Mr. MartiniAD Administrator, it seems like you enjoy leaving read access file shares for the guest account. That is a big mistake. We managed to see the notes inside there that had credentials. We then turned that into a Kerberoasting attack, which got the hash for your service account, which, strangely enough, has WinRM access. Maybe you knew about the flaws in your system, or maybe you decided to accept the risk. Well, you accepted the risk. And now we're in.
So the elevator music really sells it, yeah. Jackson America says, are you going to hack Wi-Fi? Hacking Wi-Fi, we talked a little bit about that at the end of the last stream, but I don't have any real plans to do that. All right, so we got access to this account, and I guess what we need to do is we need to run like Sharphound or something to get all of our Bloodhound information. So where is Sharphound? I don't think I've run Sharphound before. Let me see if I can find it. Find name sharphound.exe. Okay, what do you mean by network hacking? I was thinking you were going to hack Wi-Fi. You can get lots of internet without any cost. Well, I mean, it's probably better to get your own internet connection unless you trying to stay anonymous or something. Not sure, but let me find the Sharphound tool. What we're doing today is we're doing some Windows network hacking. Okay, we got Sharphound, data collector for Bloodhound over here. And let's go ahead and go to the releases. Okay, we don't have any actual exe files. Unfortunate. I mean, I guess we could also run like a PowerShell script to get Bloodhound information. So the other thing we could do is we could try to figure out if this user has some special access. So whoami/priv. So add workstations, change notify privilege, SE machine account privilege, SE increase working set privilege. Okay, 6364 says, I heard that Hack the Box Academy has some good wireless modules, fairly expensive though. So I mean, there's a couple of wireless modules on TryHackMe as well. I'm not too sure if they're free or not. We could look really quick. Okay, and we're looking for wireless security. I mean, we did this one recently, like on the last stream. Yeah, I'm not too sure. Okay, Jackson asks, do you know how to download and install actual libraries of Java to generate visualization 3D drawings? No, I don't think I know anything about that. Okay, so we're still trying to figure out how to get our our Bloodhound information. So we got Sharphound here, but they don't have any executables. Oh wait, maybe the executables are in these zip files. Okay, so which one was most recently? So let's see. Windows x86. We're looking for x86 64 maybe. Okay, so there it is. We'll just move it into our current directory. What was it called? Sharphound with a capital S. Okay, and then we need to unzip this thing. Okay, so we got sharphound.exe, and then we got sharphound.ps1. Good. So we just need to upload it to our target. I'm pretty sure we can do it pretty easily with evil WinRM. So upload this. Okay, this is going to take a little bit. So the other thing I'm a bit concerned about is whether or not the antivirus on the Windows machine is going to delete the file as soon as it lands on the disk. Okay, we've got sharphound.exe, and I'm just going to wait a couple of seconds, and I'm going to check one more time to see if the antivirus deletes this file, because Windows Defender doesn't like Sharphound. Okay, so it looks like everything's good, so let's try running Sharphound. Huh. Okay, Sharphound enumeration completed. Happy graphing. Sure. Did it actually... Yeah. So we've got a zip file over here, and we got a bin. I think what we want to do is we want to download these. So download this file. Okay, download failed. Download failed. Okay, download successful, and then we'll download the other thing, just in case. I'm pretty sure all we need is this zip file here, but we'll download this other thing for fun. Okay. And let's see. So we got the zip file here. And I think what we're going to do is we're going to start up... Man, I haven't started up Bloodhound in months. Okay, we don't need Bloody AD anymore. We'll just call this Bloodhound. We got ads running on Twitch, so we might as well put on some birds. Where we got? Okay, here are the birds. We'll be back in about 45 seconds. I just need to have a little bit of water. Okay, and 6364 asked, do you have any recommendations for something that you've watched recently? Cyber Sky says AOT, are you talking about Attack on Titan? Let me think about the stuff that I've watched recently. If you're looking for like anime, and you're looking for something that's more like cyberpunk, and like hacker related, I guess you could think about... You might think about watching Psycho-Pass. So this one right here. If you're talking about like other hacker related movies, War Games is pretty good. War Games. And if anybody has any other recommendations for hacker-like movies, I mean, Mr. Robot, of course. What else? Anyways, let me see if I can remember how to run... Let me see if I can remember how to run Bloodhound. Does Bloodhound have to be run as root? No, it's starting Neo4j. So Neo4j should be available at HTTP localhost 7474. Okay, let's see if we can access that. Oh, here we are. Can we log in? Login failed. Please try again. Okay. Was there a question during the ad break? I don't know. Was there? So Bloodhound Community Edition is not letting me log in. I think what I might want to do is I might want to delete, uninstall Bloodhound. So let's see, opening. So this is localhost 8080. Yeah. So this thing. The problem is that there's a specific version of Bloodhound that lets you know what the password is each time it runs. That's the one that I like. Neo4j is running at localhost 7474, but this is not what we're looking for. Okay, so I need to figure out how to. I need to figure out how to uninstall Bloodhound and install it again. To uninstall, we want to stop Bloodhound and then uninstall it. Then reinstall it. We're working on Kali Linux. Thank you very much for following on Twitch. Nevomac, thank you. Sudo Bloodhound stop. Sudo Bloodhound stop. Okay. It's not what they want. Stop bloodhound.service. Okay. How about we just stop Bloodhound? Where's that Bloodhound? Actually, maybe what I need to do is I just need to go in here. Yeah, or maybe we just need to stop Neo4j. Systemctl stop Neo4j. Not loaded. Neo4j.service. Not loaded. Okay, so how do we see which running services there are? Sudo systemctl. Because it's gotta be... You can stop them manually, okay? I mean, we did that, well, we tried. Remove Bloodhound and its configuration data. So sudo apt get remove purge Bloodhound. And the other thing we want to do, if you have installed Neo4j separately via apt remove it. So just get rid of Neo4j as well. So what we want to do is we want to install the version of Bloodhound that has a new, I think it was like the containerized version of Bloodhound. So let's see. Let me do a quick inquiry. We want to run Bloodhound in a container. Maybe we should just look it up. Bloodhound container. Okay, Docker image. Okay, here's Bloodhound. Let's see. How can we pull the container and run it? Probably with some Docker command. Docker pull, Docker run. Okay, so Bloodhound CLI, which automatically pulls the Docker images and sets up Docker Compose. Install Docker CE, this pulls the containers. Bloodhound CLI, do I have it installed? Bloodhound. No, it doesn't look like I have installed. Yeah. Okay, so we need to download the CLI for my OS. Okay, save that and then untar it. And then run the darn thing. So Bloodhound CLI, this is just an executable in here. Bloodhound CLI install. Wow, looks like something super awesome is going on with all these progress bars. Okay, and then wait for the, let's see, randomly generated admin password. Then access Bloodhound from the browser. Log in with admin and the password shown during installation. This thing. Did it finish? Error response. Error response. Address already in use. Oh, that's true. So we need to get rid of... We need to get rid of the Bloodhound that's already running. So psawk and look for Bloodhound. Whoops. grep on that. Okay, we need to get rid of these processes. So we need to sudo kill these things. Kill this, kill that, kill the other things. Still here, persistence is key. Trying to. Then again, we've got time limits because I don't want to stream for too long. There's still one. Okay. There's no more. We'll try running Bloodhound again. It's okay, so it says Bloodhound is ready to go, and we've got a password. So we'll just check it out. Okay, we're logging in as admin, and the password, we need to grab it from over here. So this password. Log in. Login failed, but why? Okay, you can log in as admin with this password. AD Penguin, nice to see you here. So we're just going to copy the password. You can get your admin password. You can log in as the admin with this password. You can get your admin password by running Bloodhound CLI config get default password. Okay, let's try running this and see if we get the same password. This is the same password. Okay, so let's copy this and then try to log in. Why did the login fail? Why did the login fail? Okay, so I hate dealing with Bloodhound. So we're trying to use the Bloodhound Docker. I mean, and the other thing we should do is we should get rid of all the configuration files for the old Bloodhound. Email address or username admin? I mean, the username is admin here. We don't necessarily have an email address. We only have... Okay, so when we... I think it might have something to do with some configuration files that we didn't delete. Okay, here's how to uninstall Bloodhound on Kali Linux. So we did the uninstall, and then we need to get rid of some files. So let's get rid of these files. It's asking for email address. I mean, it's asking for email address, but I've never logged into Bloodhound with the email address. The real question is, how do you shut down? How do you shut down Bloodhound? Yeah. Neo4j. What's wrong with Bloodhound? Bloodhound is not behaving very well. So I every time I install Bloodhound, it asks me to update the password, but instead I decided to go with a Dockerized Bloodhound. And a Dockerized Bloodhound tells you the password every time you start it up. But the problem is that the password doesn't work. So let's Docker PS this, and let's shut down the container. So Docker kill. Docker kill this thing. Docker stop. Okay, so if this is stopped, then if we load this back up, it shouldn't give you anything. Okay, so it doesn't give you anything, so we do Neo4j should reset also, I think. So let's run So let's just run the install file again. And then we can access the thing from this address. Okay, and then we need to use this password. The problem is I think that it might be using the password from another installation of Docker. Did it work? Login failed. So yeah, I'm not too sure why the credentials aren't working for me. Okay, I think the configs would be contained in the container, if I'm not mistaken. I mean, the Bloodhound CLI tells us that the password is this. I think I might uninstall everything. So where are the Docker passwords contained? So let's stop the Docker container. Reset password, ID your new password. Okay, is this like a Docker CLI command? Okay, let's just make it any old password. No, that's not it? Oh, no, it's Bloodhound CLI. Bloodhound CLI. Bloodhound CLI. Password. Can we make it anything we want? Test. Okay, so let's see. Unknown flag user ID. So that doesn't want user ID here. Okay, how about we get the help for this? Try no flags. Okay. just wait for this for a sec. I mean, the problem is that I keep on forgetting the password. Alright, so it's, there's a new password now. Sure. Okay. And then we try this password. Check your env file or your Docker Compose YAML files if you used one. Look for parameters like Bloodhound initial admin password. I mean, because we reset the password, we should be able to log in now, right? Oh, finally. Jeez. Okay. There we go. Okay, well, let's go ahead and import. So it's like up here, I think. Or download collectors. Download collectors. Yeah, we hacked the planet. We got our stuff to work. Okay, so these are the collectors. We want to upload our stuff. So quick upload, and then we need to select our zip file. So our zip file should be in our temp directory. Temp, where is it? Here's this. Okay, so we got the Bloodhound stuff that we got from Sharphound. Oh no, here it is. No, here it is. Okay, open this up. Upload. Successfully uploaded one file for ingest. Okay, and then we close. And then we explore. I'm not sure if we're looking at this the stuff that we're supposed to be. Are we hackers? We need to put it in dark mode. Yeah, of course, of course. Here we go. Now we're hackers. Okay, so dry.martini.bars. Okay, here's our domain. And we need to take a look at the users that we have access to. So our user is, what are they called? Athena SVC. So we need to look up this user. Here we go. Okay, so let's take a look. So usually what we need to do is we need to pay attention to member of. So for special groups. So member of remote management, member of domain users, everyone, authenticated users, users at dry. Okay. Remote desktop users. I mean, we could remote desktop into the machine. Okay, Yoke, hello, nice to see you here. I just came here and may I know what we just uploaded in bloodhound.zip? So this is a very common tool that we use in Windows Active Directory security exercises. It's called Bloodhound, and we're trying to figure out the big map of what's going on, all the relationships between the different Active Directory objects. Okay, so member of, and let's see. Outbound object control is usually something we want to pay attention to. Then again, we could also look at some pathfinding, right? So we'd go to So pathfinding start node is Athena service. And we want to get to we want to get to domain admins. Okay, so what is this? So our user can PS remote into dc.dry.martini.bar, and that means we can do a DC sync. Okay. PS remote connection, interactive session with computer abuse. Okay, and then from here we can do DC sync. Hold on. This computer has DS replication get changes. The two permissions allow a principal to perform a DC sync attack. You may perform a DC sync attack to get the password hash of an arbitrary principal using in-packet secret dump. You can also perform the more complicated extra SIDs attack to hop domain trusts. So do we... It can't be that easy, could it? Don't we need... What are the requirements? What are the requirements to perform a DC sync attack on a Windows AD network? I've done that before. I think I've done it like once or twice, but it's not something that comes up a lot. Okay, to perform a DC sync attack on a Windows Active Directory network, an attacker needs the following requirements. Okay. Replication directory changes, so these are the requirements on the network. Let's see, alternative permissions that enable DC sync, generic, all full control in the domain. By default, these permissions are held by domain administrators, enterprise administrators, domain controllers. Access to the domain controller. The attacker must be able to communicate with the domain controller over the network to send replication requests. Tooling, typically Mimikatz. So desync functionality is built into Mimikatz. Mimikatz. Okay. Network protocol access. Okay, what's my absolute hard limit on this box? If we can't get this done in the next 10 minutes, we're gonna have to call it. So let's go ahead and set that time limit up. Okay, so what Bloodhound suggests over here is to use secretsdump.py. So where is this thing, huh? Okay, which secretsdump.py? Secretsdump.py not found. It's usually included in an packet. Secrets dump. In packet. Let's find name secrets dump. Does this script not exist on my machine? Really? Locate in packet. So in packet is here. So in packet examples. So secrets dump is usually in one of these. It's usually in this directory here. Secrets dump.py. It's here. Why wasn't it not able to find it? Okay, let's run the thing. Python secretsdump.py, and then the rest of the command. Okay, we need to provide the DC dry.martini.bars. We're using the Athena service account. Okay, so the Athena account with this password. Was like one dry martini. Let me double check that. One dirty martini, okay. At domain controller, and the domain controller is dc 01.dry.martini.bars. Okay, so it didn't work. So session error, the distinguished name specified for this replication attack operation is invalid. So it might have something to do with my parameters here. Which IP address? Okay. Okay. The distinguished name specified for this replication attack is invalid. Alright, so we'll just ask the we'll ask the AI what's wrong with the command syntax. Wrong with this Python command syntax. Okay, the main issue is missing the DCIP flag in the current incorrect quoting. So let's see, missing DCIP. I don't know if this is correct, but Overquoted domain. Overquoted. No quotes needed. Overquoted username. No quotes needed. Overquoted password. No quotes needed. Overquoted IP. Corrected command. Okay, and then, well, let's just run what they're recommending here. Okay, so something is up with the command that we're given here. Dry martini bars. Let me take a look at let me look at my notes. I'm pretty sure I've done this DC sync attack before, and I'm gonna take a look at the command syntax I used before. Oh, I see something for another HackSmarter machine that we did. But then again, we're using. Let me see if I can search for like a DC sync. Apparently, we run this command, inpacket secrets dump. And then we provide let me look this up. Inpacket secrets dump. Am I barking up the wrong tree? Because this account can PS remote into the domain controller. Maybe I can't actually do the DC sync attack. And SHM Rad, hello, nice to see you here. What is up with you? Maybe you need something lateral? Yeah, I mean we can remote into here, but I'm not too sure if we inherently have this stuff here. I'm gonna have to come back to this because I've run out of time. All right, everybody, what are we doing? So this is week 22. We've just finished, and next week is going to be week 23. we're going to be doing some new stuff over at HackerFrogs. Our schedule is over here. And in the meantime, let's see if there's some awesome people that you can raid over on Twitch. Just a second. InfoSecStreams.com has a bunch of cool people who do cybersecurity content on Twitch and on YouTube. And right now, it says that Theo's streaming, but I don't know if that's actually true. Let me check out my Twitch. Yeah, he's not streaming right now. See, Rob's streaming. And MSec is streaming. Let's stream Rob. I haven't raided into Rob's channel in a while. Last time we raided into MSec's channel. But there's also science streams. So science streams also a cool channel. Let's check him out. Over here, and they're usually doing science content. Okay, they're talking about monkeys. Monkeys? Monkeys. Okay, let's send them a raid. Okay, so everybody, we'll be back on Wednesday of next week. But I hope everybody has a great weekend. And if you're interested in taking a look at the Reddit and the Discord, they're over here. All right, everybody. When you arrive on Science Stream's channel, if you could give this raid message: OSFrog, Hip Hop Hack, OSFrog, I would really appreciate it. Okay. All right, everybody. Thank you very much for watching today, and we'll be back next week. HackerFrogs out in 5, 4, 3, 2, 1. See you next time.